Hi everyone. If you could please take your seats, we're going to start in a minute.
So good afternoon, everyone. Welcome here to the final event, and please take your seats. And again, good afternoon. I'm very happy to see you all. I'm Anita Derjanes, Managing Director of REVA, and I'm really happy to host and see the final event of the 3H projects. I attended the very first meeting, and now we can welcome also the final event to see the result, and then also have a very timely updates on the related F-gas regulation review. So I would just like to welcome everyone and also the consortium on REVA's behalf, and then hand over to my colleague Jasper and thank them to organize this event, this excellent event. Jasper and Sophia and Marie, my colleagues. Thank you.
Thank you, Anita. A special thank you to my colleague Sophia, who could not be here today because she has fallen ill. Nothing serious, but she couldn't make it today. But she has put a lot of work in this event, so special thank you to Sophia Bazzano. I hope you will enjoy the afternoon. So we will have a 4-hour event in total. The first session will focus on heat pumps based on natural refrigerants. We're going more into the technical side of the role of natural refrigerants in heat pumps. Why are they good or not good? What are the risks? And so this will be more technical. And then in the second part will be really more about the F-gas regulation and the proposed phase down of HFCs and HFOs. Based on the Commission's proposal, we will have different presentations to discuss this. By different EU institutions and by different researchers. So I think because time is short, we can start already with the first session, and I will hand over the floor to Daniel Carbonell, who will moderate and also present the first session.
Thanks, Jasper. I would again like to thank REVA and especially Jasper and Sophia again for the organization of this very nice event. You did a very good job. So I think this would be a very nice afternoon. So in the first part of this workshop, we will present a bit. Consortium partners of 3HP will present results of 3HP, but focus a lot on natural refrigerants and what is coming next. So most of the results will not be presented because we don't have the time for doing this. But a lot of these results already exist and can be looked at. And I will show you some important things we did so that you can always go and have a look at it. So I'm Dani Carbonell. I work at SPF, the Institute for Solar Technology, and I'm the coordinator of the project. And in the first presentation, I will give you an overview of the project itself and some small results that we achieved so that you can have a look later on if you have an interest. So 3HP stands for 3 generation systems, based on heat pumps with natural refrigerants and multiple renewable sources. It is a EU-funded H2020 project, Research and Innovation Action, and the idea was to move technology from TRL 3 to 5 so we can demonstrate things and validate them in the laboratory. It's about 5 million euros and started 4 years ago, and it's finishing end of this month, so we are at the very, very end phase, and that's why we have this final event here. Here you can see the consortium partners' logos. And the main idea of 3HP was to develop what we call 3 generation systems, so systems that can produce heating, cooling, and electricity. And we are doing this using natural refrigerant heat pumps that can use multiple renewable sources. And our main target was to achieve 80% of on-site renewable share, and doing this in a way that we can save costs compared to current technologies that would have the same efficiency by 10 to 15%. So cost drivers was the main reason why we developed this concept that I'm going to show. And this also brings as a consequence reductions in gas emissions. So basically we developed two kinds of systems. One is what we call dual sourcing system. Basically in THP we are developing a lot around the heat pump. So the heat pump is the main development and heat exchangers inside this heat pump. And this heat pump has a feature that it can use both borehole and air as a heat sources for heating and heat sinks for cooling. So this system is meant to be used for heating and cooling, so South Europe where both demands are necessary. And the complete system is controlled by an advanced energy management system that can not only deal with the heating and cooling demands and the storage, but also with the electricity part of it. And it uses motor predictive control. The main development was meant to reduce borehole length by a factor of 2. And this is what it brings, like about 10 to 15% cost reductions in the installation cost. The second system is what we call a solarized slurry system. That's a particular case of a solarized system, which is a system that it's maybe not very well known, but exists in Central Europe, Switzerland, and Germany. And it's a system that has a capacity to use solar thermal collectors as a heat source for the heat pump. And because solar thermal is not always available, what we need is an ice storage to compensate times when solar energy is not enough to give enough heat to the heat pump evaporator. And that the innovation we bring here is that instead of using a conventional ice storage, we use an ice slurry that I'm going to present later on. This system is also the capacity to be controlled by an advanced energy management system and also includes all the photovoltaics and electrical parts of it. Now what exists today in ice technology, it's what we call ice on coil. These are examples of Wiesmann and Isokol. What you see on the top left, it's a system under construction. So they take a room like this and they installed tubings. And when they finish with this installation, you get something like in the top right, so there are tubings everywhere. Yeah? The reason you need to do this is because otherwise you cannot extract the latent heat of energy of water, otherwise you will not ice all the water. But of course you can imagine this is quite costly. You are adding tubes everywhere, plus ice builds on the heat exchanger, on this tubing, and this decreases the efficiency of heat transfer, and then over time the thing gets less efficient. And also concept-wise, this concept scales with the energy, so you need more energy, you need to have more power also, so you cannot decouple the two things. And in order to reduce cost, and this is a cost driver of this kind of systems, what we have developed is an ice slurry technology using the supercooling method. And the idea was, can we have an ice storage without any heat exchanger? This will reduce massively the cost of the storage. And this can be done with ice slurry. The problem is conventional ice slurry technology uses ice scrapers, which are very expensive and has a very high maintenance and operation cost. So we develop a new technology. Well, it's not new, but it's not done in Europe yet, which is called supercooling technology. So the idea is simple. We take water. Let's see if this works. No. So we take water. We cool it down below the melting point. And then water is in a supercooled state, in liquid form. We continue to cool water until we, by purpose and in a controlled manner, crystallize. This is a device called crystallizer. And then latent heat of energy is released. And what you get after this is an ice slurry. So basically ice particles in water that can be pumped. With this concept, you don't need heat exchangers in the storage, but you have different challenges. One is you have to supercool water in a stable form, and you have to crystallize in a controlled manner. Yeah? The difference between the melting point and the actual crystallization point is what we call supercooling degree, and the higher the supercooling degree, the higher the probability of freezing. So in order to achieve stable supercooling degree, we develop what was called isophobic coatings. So coatings that are able to delay the formation of ice. This was developed in material science, and these coatings were applied into brazed heat exchangers, and we applied these brazed heat exchangers into real heat pumps. This was one of the developments. And then to develop the other heat pumps, the dual sourcing heat pump also needed a special evaporator condenser, the dual heat exchanger, which is basically heat exchanger that can exchange heat directly with air and with ground. So the refrigerant has direct contact with both heat sources and heat sinks, and that's the main innovation of this development. Systems that exist today are indirect. And then we also developed what is called a tripartite gas cooler. So that's for CO2 transcritical cycles. And as you know, CO2 is very good for domestic hot water because a large delta temperature into the gas cooler, but for space heating it's not good. And this heat exchanger has a preheating unit for domestic hot water, reheating unit for domestic hot water, and the middle section is for space heating. So we can produce simultaneously space heating and domestic hot water at very high efficiency. These heat exchangers were installed in 3 heat pumps. Actually, we developed and tested 6 heat pumps. We did 3 prototypes, 1 dual sourcing prototype, 1 propane ice slurry, and 1 CO2 ice slurry with the supercoolers and the tripartite gas cooler. We developed 3 of them, we tested them, we improved them, we developed 3 more and tested again. So we tested actually 6 heat pumps. And then we moved these heat pumps into a system level. And the first part was to have an advanced energy management control system, able to control all this system in a very efficient way using model predictive control. The AMS uses 24 hours forecast in order to decide what to do in the next time step. And this allows us to reduce operation costs by 10 to 15%. This was tested numerically and then implemented in a real system that was tested in the laboratory and successfully tested like a few weeks ago. In order to test the systems, we use what is called a concise cycle test. So we started from materials, went to heat exchangers, went to heat pumps, and then went to systems. Yeah? And in order to test the heat pumps in realistic conditions, we use this method, which basically allows us to install physically in the lab what we want to have and what we have developed. This, in that case, would be what you see here in blue: storage, heat pump, battery, controls, hydraulics, and the system is operated autonomously. So we don't touch it. We let it run for 14 days, and then it gives us the result. And the days we select for testing the systems are representing a year. So 7 days are usually represented for a year. Or when we have advanced energy management system that we need model predictive control, then we use 5 consecutive days to represent a season. And this kind of test was done for 3 systems. Here was done for the dual sourcing in Tarragona, in IREX laboratory. So they installed physically what you see here, the storages, also the battery, the inverter of the PV, and the dual sourcing heat pump. And the rest of the system is emulated and simulated. So basically we have a simulation model that tells a real emulator to give the response of a virtual element. So then the conditions that the system is submitted are very realistic. And I would say the devices that are installed physically get to TRL 6, and devices that are emulated, simulated, or the complete system maybe go to TRL 5. So we are in this range, very close to go into a real system. We also tested the solar ice slurry system with propane and with CO2. You see the 2 pictures here. So here we also have the heat pump, the emulator here, the ice slurry was emulated because of the space. And then the storage tanks were here, and all the hydraulics were also implemented. In terms of results, I cannot show, these results will come up in a month of all the system tests. But I would say in the solar ice slurry system, both propane and CO2 got efficiencies above 4.5, which is beyond or what you could get maybe with ground source heat pumps. And very importantly, for us was a very challenging thing to prove that we can supercool water in dynamic conditions in a stable form. And this was achieved. Here are, for example, some results for the CO2 heat pump. The heat pump was tested, CO2 system, the complete system was tested for 14 days. I'm here showing from day 4.5 to 7.5. This is temperature, this goes up to 70 degrees, and this is what the gas cooler does for domestic hot water, so we can reach 70 degrees, no problem, or 60 something to 70, and this is space heating, 30, 35 degrees. And this is the temperature in the evaporator. And these are the winter days. And when you can see here, there are more than 40 hours of supercooling conditions. So water outside the evaporator was below 0 at -2 approximately, constantly for almost complete 2 days in dynamic conditions, not a single freezing. So we could achieve this thanks to the large developments on isophobic coatings and heat exchangers and all this process. So the systems were demonstrated in realistic dynamic conditions. And you will get access to all these results in about 3 to 4 weeks. And last but not least, we developed a lot of technical things, but we wanted to know whether they can be deployed. And for this, we need acceptance. So we had a lot of work on social acceptance to prove and to see whether we will get barriers into the deployment of these technologies. I'm not going into the details because you have a very nice presentation afterwards, so I left the experts to talk about this. So that was it. I keep it short. I'll leave the room to my colleagues to go more in details. Thank you very much for being here. So next presentation is by Rafael from Heim. Thank you.
Thank you very much, and a warm welcome again. I am with a heat pump manufacturer in Switzerland called Heim, and I was given the opportunity to share an industrial point of view and some experiences, some results within the project. So we were part of RACHP and had the opportunity to produce some heat pumps. We are passionate and working hard towards shifting to natural refrigerants. So looking at the map of refrigerants that are available today, we all know that we have the challenge that there is no ideal refrigerant. Some are flammable, some are toxic, some are expensive to apply, some are very toxic to the environment. There's no ideal refrigerant, so we do have some challenges. We do have to transition, and I would argue that we should take the good step towards natural refrigerants, and this is why. There is one main reason. There's different reasons, but there's an elephant, and the big one really is using natural refrigerants means we use substances that have been known in the atmosphere to the environment for decades, that are safe for us, that are safe for the environment. With this, there's, for me as a manufacturer or for us as end users, there's other advantages as well. So with the first big argument comes the advantage of no restrictions. I don't have to leak test my system. There's normally also no blends. We don't need different synthetic refrigerants mixed. We go for the natural ones. There's very practical reasons as well to use natural refrigerants. They are very well available. They are cheap. I don't run the risk of sourcing because there's risks of availability. We all have experienced the risks of sourcing components. It's the same with refrigerants. A small detail, which is a big argument for bigger companies like Roche, who chose to go natural only, is that they don't want the variety of, I mentioned, mixtures, cocktails of other substances. They just cannot handle the variety of a lot of refrigerants. So we need to keep it simple, choose the solutions that are proven. Last point, if energy efficiency. In many applications, we can use natural refrigerants very efficiently. With this, of course, comes a lot of benefits, operating costs reduced, CO2 emissions reduced, and more. What I have found working more or less with naturals for 2 decades now is that components become available, they are well available, and they improve. They get better and better because some are new, some technologies are new, and they become more and more efficient. If we look at some applications and groups of natural refrigerants, I only put down applications within heating, ventilation, and air conditioning, not talking too much about refrigeration or other applications. There's one big group, the hydrocarbons. We can use them for heating and cooling. There's really good opportunities for high temperature applications. So heat pumps are taking off in industry for very high temperatures. We all use them at home in our home appliances in very small quantities. If you have a fridge or freezer at home or a dryer, they use hydrocarbons. The other group is carbon dioxide, which is widely used today in different applications. CO2 is really good for high temperature lifts, especially domestic hot water is a classic and really efficient application. There's other fields like mobility, trains, buses, cars, where CO2 would be is very well suited if we have heating and cooling at the same time. Of course, it's also used in industry, in space heating and cooling in general. Then we have ammonia, which is a very old, very good, extremely efficient refrigerant, a proven technology that is used in mainly medium and large size applications. We have ammonia in sports, in entertainment, cooling, heating and cooling, a lot in industry. It really is a proven refrigerant. Then we have a fourth group, which I would call niche, which is very promising, developing. We could use water or air as a refrigerant. As mentioned, we had 6 heat pumps produced within the project, RACHP. On your left side, you see 2 heat pumps, first and second prototype with this dual source heat source, which is mostly targeting cooling dominated buildings. On your right side, we have 4 heat pumps that are mainly targeting heating applications, 2 of them with propane, and the right 2 heat pump prototypes with CO2. Now going a bit into details and showing some examples within hydrocarbons and CO2, I would like to start with looking at propane. There's many products available out there. A lot of us are not too much aware of it, but I had the chance to look a little bit into the market and Google a lot and found out there's so many products available with propane. Indoor, outdoor installations, all of them reach very high supply temperatures. I will look into that later on, but they reach 65, 70 degrees supply temperature, which is very helpful and interesting in heating applications. They all come plug and play. They have their safety concept incorporated and ready to use. Different applications, water, air, air to air, a lot is available. One of the reasons for us to go with propane as a manufacturer and for the customer is propane comes with a very wide application envelope, a big advantage of being able to supply water up to 70 degrees. On the right side, I have put together 2 compressors that we commercially use. We still use HFCs, we are transitioning, but also propane. So comparing the 2, you can see that the dashed line is the application envelope of a compressor with R410A, and the larger envelope is propane. What is a very important area for us is the bottom left, where we have low ambient temperatures and high supply temperatures that we need. There's other advantages as well, of course, negligible GVP. It really is a future-proof product or refrigerant. Now you might ask, how do you assure safety? It's always the question. Of course, we need to make sure we have safe installations because it's a flammable refrigerant. There's different possibilities. Outdoor installations are easily done with a product that is safely installed. You normally need around 1 meter of safe area around the heat pump. You need to make sure there's no openings to a building where propane could accumulate. And of course, you're not allowed to have any sparking elements within this 1 meter. But outside installations are really easy to do. There's normally, the charge limit is at 5 kilos or sometimes even more. If we go indoor, it gets a little more complicated, but there's many solutions available. So below 150 gram, you can basically do everything you want. It's your home application that normally have 100 grams of propane. Or anything below 5 kilos, you can do a ventilated enclosure. And I took the liberty to show a picture of our newest product that we developed in parallel to RACHP. It's an indoor heat pump, brine to water application for up to nearly 30 kilowatts of heating capacity. And anything in between 150 grams and 500 grams, there is a standard that gives you a lot of opportunities. Looking at if you have a sensor, if you have a fan that is circulating air, you can look at the area that you install, the height, and this gives different charge limits. So we are typically looking at around 500 grams that we can use for a heat pump, which gives decent capacity. Within RACHP, this is the second prototype that we produced with propane. It has got a tight enclosure, a ventilated enclosure in case we would have a leak with propane. So there's a sensor inside that would detect the propane, activate the fan. So there's an ATEX approved fan inside the enclosure. There's a duct leading to a safe area outside. We need to make sure that there is fresh air coming to the room, but if not, we just install an additional pipe. So this was the safety concept that we used. As mentioned, it has this supercooling evaporator included. Some results, just as an example, the prototype was tested at SPF, a lot of data acquired. This is just an example for water temperature of 10 degrees. You can see the capacity and the performance of the heat pump at different compressor speeds. We can see that the COP decreases with increasing speed, what we expect, but this is mainly for low supply temperatures. Astonishingly for me as an engineer is if we have very high supply temperatures, the COP pretty much stays constant. Now switching to the second group, CO2 as a refrigerant for heat pump applications. Again, there's a lot of products out there, many for domestic hot water applications. On the right side, I have put a chart that I stole from IKZ about the demand for heating in domestic hot and domestic applications. We need to realize that domestic hot water increases if you look at the total heat demand. So new building, net zero buildings today, they typically have a heating demand for domestic hot water of at least 50%. I have put down two examples to show the success of new technologies and the opportunity that we get with natural refrigerants. Many would know the success story of EcoCute, which is the name for CO2 domestic hot water heat pumps that have been sold millions of pieces in Japan, also a bit in Europe. I have talked to an old friend that I have that started a company, Fenagi. They started 3 years ago with producing really large CO2 heat pumps. They are doing extremely well and it's just taking off. They were selling 20 megawatts of heating capacity within the last 2 years. He told me they will sell approximately 40 megawatts this year. This is the prototype we built with CO2 and measured at SPF. It's got a variable speed compressor, the heat exchanger mentioned, the gas cooler, the three-part gas cooler. And we have implemented some measures to increase efficiency. So there's a flooded evaporation, there's ejectors involved to make it efficient as necessary. We talked about this three-part gas cooler. So I wanted to show an example of how it was operating. I was very encouraged to see where it was actually running. So we had, as an example, we were running the CO2 system at nearly 80 bar, a standard domestic heating application. We extracted around 4 kilowatts of heating for space heating and roughly 8 kilowatts for domestic hot water, which is not the 50-50 ratio I mentioned. This is just an example. But we could reach very high temperatures. We can reach 70 if we want. In this example, we are heating up water from 15 to 53 degrees. And we reached COP of over 5. Now, if you look at the left side, the red line is what the CO2 does, the transcritical heat rejection with this nice transcritical behavior. And what we want to do with the RACHP is approach this curve. And I was astonished at how close we get, proving the really nice heat transfer properties of CO2, because the approach is very small. So to conclude, I would say hydrocarbons can be used safely. CO2 can be used efficiently. We have ammonia that is a proven old and really good refrigerant. We have air and water that we rely on every day. So let's leapfrog every short-term solutions and switch to natural refrigerants. Thank you.
Thank you very much, Rafael. So we can go to the next presentation. Armin, I think you can present yourself.
Thanks, Danny. My name is Armin Hafner. I'm professor in refrigeration technology in Trondheim, Norway, and it's a pleasure for me today to be here to look a bit on the other side of the heat pumps we have talked so far. So what else is in the market? So the applications of CO2 and some propane heat pumps I want to show in the different sectors. First of all, a short introduction why natural working fluids are real solutions for the end users. I give you some examples, a summary and a conclusion at the end. So the state of the art mainly is that the use of the F-gases, which we have used the past decades, they have a severe impact on humans and the environment. That's why we are here. That's why we see in the next slide there is an issue. And today we are not talking about anymore in this part of the world on ozone depletion, but that's still a case in other areas. Other areas are still allowed to use these fluids. Global warming due to these fluids, which we want to get rid of, and the acidification of our water, that's a severe issue, and the poisonous decomposition of these products. So these PFAS, the parent polyfluorinated alkyl substances, that's something we don't want to have in our mother milk, in the water, and food. And I think we are all agree on that. So what are sustainable working fluids? Not this one. We are coming from the upper triangle, the carbon-based stuff. We have ozone depletion with this part. As long as there are chlorines, no good. We are done with that. Now we have these other solutions, these ultra-low GWP fluids, which have more and more fluorines. The more you come to the right, they are proposed as the next generation. However, there are issues. They are decomposing to TFA. That's this PFAS. And we don't know what's really going on with all these decomposition products. Still, some of the scientists see there is a challenge. And last but not least, what we talk later about, the F-gas regulation, the definition of the global warming potential, that's a big, big issue. Because LCA-based is not at all. It doesn't include manufacturing data. It doesn't include the decomposition. So it's just a narrow day to day. You get more information on PFAS there. However, today, the government And ECHA has released the restriction, which will be the end of the F-gases applied in refrigeration. F-gas regulation takes care of R32. The ECHA PFAS restriction will take care of the rest. And this is kind of the waterfall some of these manufacturers are thriving towards. But don't worry, there are solutions. Nobody needs to freeze or so on. We can create comfort with natural working fluids, both for industry, homes, and else. I show you some example. It was nicely mentioned before, there is high temperature heat pumps. Yes, that's something for industry to make the transition away from fossil fuel boilers and stuff like this to produce, for example, steam with some surplus heat. We look at simple commercial refrigeration system for supermarkets. I will show you a heat pump chiller for hotels, gyms, kitchens, and so on. And I show you also integrated heat pump for energy central. I'm not looking into mobile air conditioning, which is another topic, ice rinks and all this stuff, freezing plants, or cold thermal energy storage, plus. So this is an example of a high temperature heat pump utilizing propane and butane. And the beauty is here, if you can see on the upper right hand side, it produces about 150 degrees C pressurized hot water, which is utilized in a dairy. On the other hand, on the low side, it produces ice water around 1 degree, which is also used, of course, in the same dairy to cool the milk and the yogurt and all this stuff. So producing cooling on one side, hot water on the other side, which is used for cleaning purpose and all this, can be done with this kind of hydrocarbon heat pump. Very efficiently, the end user is very happy, and it's just one pilot and they are asking for more of them. In this case, it's producing on this process. You see, the process heat is about 117 megawatt hours, hot water, about 10% of it. The process cold, on the cold side, is 77, and the ratio, you can calculate your CUPs in all directions. This is a successful unit. It runs 24/7 at the dairy because they are so happy. They save money every day. Another simple, efficient system for supermarkets utilizing an injector has been proposed by my colleagues and me, and we propose it because it's very simple. On the medium and low temperature, we need only one compressor set, and the beauty is we can use it wisely in a way that in the summer we have higher ambient temperatures, we have a potential to do recovery of expansion work. Then we utilize this nice unit, we run it in the mode, as you can see, and the high pressure, this is a bit technical, but the high side pressure is controlled by the ejector. So that is nothing new, but it is kind of unique to go the other way around in winter and just bypass this unit. And if you don't need the heat in the supermarket, we can go on a very low high side, which is very energy efficient, and the condensed refrigerant is guided directly where we need the liquid to be evaporated in the cabinets, where the milk and the cheese and whatever is to be cooled. And we just bring the vapor via the ejector back to the compressor in a very energy efficient way and very simple. The problem in the past years was ejector technology is too complicated, not easy to maintain. Technicians do have super training and it's still complicated. This is very simple. That's why we will see this more. A bit technical here, we use the ejector in the winter just as a passing device, and the pressure drop through it is negligible. It's 0.1 bar, is nothing in refrigeration. So that's why it's so simple. You can use it when you need it, and when we don't need it, we just bypass it. So just to prove this, these dots show the energy efficiency of a supermarket refrigeration system based on the gas cooler outlet temperature, which is more or less the ambient temperature. At high ambient temperature, we see that, of course, all of the systems need a lot of energy to operate, to provide the cooling. But we can see that compared to the traditional booster system, which is state-of-the-art in Northern Europe, even in Germany, we can elevate the COP accordingly to the green dots when we apply this kind of system. So high energy efficiency without any parallel compression. It's a simple system, remember, simple. Still very good, much better than parallel compression, which is much more complicated. Even in low temperature application, we can further boost the energy efficiency. And that's money for the shop owner. They don't care about what's inside, but they care about the energy bill. And this is what they're all very happy if they convert to CO2 system. I have not met one shop owner who has regret that they switched to CO2 because they save so much energy. And that's money for them. And you know, these guys, they know how to run business. They want to save money. And the first system you can see at EuroShop in a few weeks in Germany on this fair. Another system I want to show is a heat pump chiller. This is made and installed in India. We have some projects with some Indian companies, and we help them to install this kind of system because in a hotel, even in Europe, you need hot water for the people and you need cooling for the building and other devices. So it's a perfect match, and I don't want to go into the details, but this is something which has a short payback time, even in India and in Europe as well. I will show you some examples. It's also available in Europe. But this is the way to go further. After the supermarket, we will see a lot of CO2 system in hotels because we have simultaneous demand on a day on hot water and cooling. And this is a perfect match for a CO2 system. This is, for example, one system you can buy off the shelf already, which has this function. Another system would be for bigger houses, bigger homes, multiple family homes is an example. And here we show a 4-type supply system. It provides 4 pipes into the building from the machine room. You have on the left side, you see the hot water, which is going through a heat exchanger, providing the heating for the apartment. If you tap water, it goes straight through. If you don't tap, it takes the water and sends the reduced temperature water back to the energy system. You have the cold water, and in many countries in Europe, you lose a lot of cold water because people want to have a glass of cold water. So they open a tap, a lot of water runs through until it gets cold. Millions of liters of water are wasted by this. We can cool the water with the heat pump, and we can use this cooling for making comfort cooling in the building, in the apartment, and send the heated water back and recool it again with the CO2 heat pump. By doing so, we save water, a lot of water, and you can provide with 4 pipes in the building only all the functions. That is what the guys building, or the persons, the company building these houses, they like. It needs to be simple. And even the plumber can understand this system. That's important. And storage is mentioned, how we do the storage on the hot water side, and how we arrange a kind of 3 HP heat pump here. It can do all this function, actually. So the heat pumps are there. The distribution is described, and we have seen some of these are already implemented. There is also commercial product similar to what I just mentioned, off the shelf again. It is there. It's just we need to be aware of, and we need to do it. So, and the latest news, we have successfully tested another kind of energy recovery device last week in our laboratory, helping again CO2 applications from small to large size to recover some of the expansion work, further boosting the energy efficiency. So that is quite promising. We will hear more about that soon. To the summary, during the last decade, significant development, as Raphael has mentioned, has been done on components and systems. energy-efficient heat pumps and chillers are available with natural working fluids. The market has accepted these kind of technologies. And last but not least, the end user is very much aware of this, which is good. However, it must be robust, it's easy to service, and the people need to be trained. But that is possible. All temperature levels and all applications can be cooled by applying natural refrigerants, which means clean cooling. There is no technical barrier to replace the current used synthetic fluids. It's more about seeing the possibilities than the ghost, selecting the optimal refrigerant for the project you have. No single refrigerant can cover all applications, as Raphael has showed. There are different natural working fluids who can do the different topics. However, the group of natural refrigerants can cover all the applications which can be covered by the F gases, which we call dirty cooling, and even more. So, none of the fluorinated hydrocarbons can go as low in temperature or as high as the natural working fluids. They cover only the most profitable market so far. With respect to PFAS, the pollution, the refrigeration sector, we all have the possibility to spearhead a complete phase out of HFCs, which is dirty cooling. This you have to admit. To PFAS accumulation in the biosphere, and we are not compromising safety, food supply, and human comfort. This will be the discussion later on. Looking forward to that. Thanks for me. And the next speaker, please.
Thanks, Armin. So the next speaker is Sabrina. I personally welcome you because the others are consortium partners of 3HP, but we thought your presentation would be very nice to complement it. So thank you very much for being here.
Okay. Good morning, everyone. So I'm Sabrina Munao, a market researcher for Atmosphere, and today I'm here to talk with you about market. Sorry, one second. Market for heat pumps based on natural refrigerants, current status and projection. Just a few words about Atmosphere. As you know, we are a global independent market accelerator with a mission to clean up cooling and heating. It's more than 20 years that we work in this industry with a team located in the US, Japan, and Europe, and working with leading companies that have new solutions using natural refrigerants. More or less 7 months ago, we published one report about heat pumps. So it was accelerating the use shift towards natural refrigerants domestic heat pumps. The objective of this report was to highlight the potential impact of the proposed HFC phase-down bans on the domestic heat pump sector in Europe. The scope was heat pumps for space heating and domestic and sanitary water heating application with a capacity below 12 kilowatt. Some result. The manufacturer that already set up production lines based on natural refrigerants experiencing up to triple-digit growth in their market segment and high demand. So the demand was very high, almost difficult to satisfy. And the manufacturer reported the confidence in their ability to quickly scale up production and reconvert all the technology production lines pushed by the right policy framework. So even a stricter phase down can accelerate the shift from fossil fuel-based heating system to clean heat pumps. This report is available on our website, so you can download for free if you want to see more results. And we did this in collaboration with ECOS, EEB, and ECF. And what we can see in the last 6 months is that really every week there are news. Every week we can see new company, new product, and so we looking for the market, in the market for new data and to keep everyone updated on that. What is the situation in the global market? So in 2020, there was 180 million of heat pumps. Heat pumps used mainly for heating. And in 2021, there is one growth of almost 20%. So the number of heat pumps need to rise 600 million by 2030 to be on track to meet a goal of net zero emission by 2050. So our goal is 600 million global, worldwide. And if we keep this growth of 20% each year, this goal is something that we can achieve. What's the situation at the European level? So heat pump sales grow of 34% in Europe in 2021, considering hydronic, air-to-air, and sanitary hot water. So in 2021, were sold more than 2 million heat pumps, compared with 1.62 million units sold in 2020. So if we analyze this chart, where the data is divided by type of ambient heat source, we can see that the hydronic sector showed the highest growth. Looking at the estimation from by JARN, the hydronic heat pump market grew of 46% in 2021. And we know also that the hydronic sector is the most suitable for natural refrigerants. The Repower EU measure is aimed to have 30 million heat pumps by 2030 in Europe. So again, this data is give a positive feeling that this goal can be achieved. As the other speakers say, natural refrigerants is a reality. Is available for all applications. Is a credible alternative. And again, you can find for domestic application, commercial, industrial, transport, cooling sector. So in all the application, we have a natural refrigerants solution available. And not only one refrigerant, we are not limited in the choice of one natural refrigerant. There are different options available that compete with each other, and at least 4 different natural refrigerants can cover heat pumps and chillers application. So this is a reality. Some situation now about market penetration rates. In 2019, this was the situation where 80% of hydronic heat pumps contained still HFC 410A, with still HFC 134A in the second most common. The other two, the R32 and the R2090, is growing. So we start from a small market share, but this is growing so much that in a few years there will be a move away from HFC 410. This is one study presented, made by the OCO Research, showing the market penetration rate related to refrigerants for new domestic heat pump installation in Germany, with the projection until 2030. In this study, we can see that by 2030, 30% of new domestic heat pumps in Germany will be charged with propane. even if there are in these years still high quantity of HFC 410 and also HFC 407C, if you can see in their projection, these are refrigerants that are going to disappear. These research were updated because OCO Research made an update of this research and interviewed the manufacturer. Of course, the manufacturer give a little different panorama of the market, because what they say is that the blend 454C, 455A are overestimated. They don't plan to use this solution for a long time, so it's only a transitional solution. And also the percentage of propane increased quicker than showed before in this study. There is another important information that we take in consideration is the market penetration rate from the European Commission, following a different scenario, from the baseline scenario, Montreal Protocol scenario, to proportionate action and maximum feasibility. If you're looking at this data, in the decade 2024-2036, the hydrocarbons penetration grow to 56% in the baseline scenario, to up to 97% in the proportionate action scenario, for example. And again, the HFCs that still have market rate in the now, they're going to disappear. So in any scenario, from the more conservative to the others, they're going to disappear very, very soon. In this research doesn't provide penetration rate for blends that is normally used also in Germany, as HFC 454, 454B, 454C, and so on. Because there are a lot of models and product already available, this overview, also if it is from 2 years ago, already show a big number of products available in the German market. And again, in the last few months, we experiment news about new company that switch at least on one line of production, new models, more capacity of the product, and also new technology. So any issue that can be, there is a new technology can represent a solution. And this is some example. So European manufacturer announced EV investment to scale up the production of heat pumps. And the path to changing to natural refrigerant alternatives became even more obvious for ensuring a future-proof and sustainable installation. So here there is just some of the news, Viessmann, Panasonic that launched one home propane air-to-water pumps, Quantum that invest millions on propane residential heat pump, Daikin that introduced the first residential propane heat pump. So every week, there is some news to show. And this is possible also thanks to the national subsidies. For example, in Germany, the subsidies for heat pumps cover up to 40% of their cost. And of course, heat pumps using natural refrigerants are favored, so there will be an extra 5% bonus if end user use natural refrigerants heat pumps starting this year. And from 2028, only natural refrigerant heat pumps will be subsidies. Last, just a precedent how the bans work with the commercial refrigeration. Natural refrigerants in commercial refrigeration show that the bans worked to speed up the market. So if you see in this chart, in the last 10 years, natural refrigerants have taken over commercial refrigeration. From less than 10,000 supermarkets in Europe using natural refrigerants in 2015, now we are almost 60,000 units. It is an exponential growth. So the stronger growth was around the year when the F-gas regulation came into force in 2015. So between 2014 and 2015, we had a growth of 67%. Between 2015 and 2016, 59%, and the last year, 48% plus. So this shows that the market players are attentive to policy regulation and can respond promptly. So we are working on a new report, so we'll be ready in spring with new data and information also directly from manufacturer. Because again, the market is in movement. So thank you very much.
Thank you, Sabrina. So now we have the last presentation. And after that, we'll have a Q&A session where we can have questions from your side. So, Emmanuel.
Thank you, Danny, and good afternoon from my side. I'm Emmanuel Sties. I'm working with the Institute for Social Ecological Research in Frankfurt as senior researcher. I'm a social scientist, and I present research which I've done with my colleague Thomas Friedrich, who is also here in the audience. I will talk about social acceptance of heat pump, and I first want to present results from a stakeholder process we have been carried out as part of the RACHP project. And I first want to go to the background, why care about for social acceptance if there's such a market penetration now, a rapid market penetration. What can we learn from this study on social acceptance? And I will go with you through some steps of our research and bring you some of the findings related to how to improve social acceptance, or in particular how to market acceptance, how to improve market acceptance. If you look at Europe, you see there is an increase in market penetration of heat pumps, but it's not equally in all countries. And that's very interesting to understand in which countries it is going well, and in others it's not so going well. And in particular, we see a difference between newly built homes and multifamily houses which have to be refurbished, which is a really large market share and a really important part of the energy transition to improve or decarbonize this part of the this part of the building sector. And this is also very important for heat pumps. So our research was to understand not only the overall picture of social acceptance, but to understand how different stakeholders think about heat pumps, what are their needs, what are their interests, but also what are barriers for different groups of stakeholders, and also determine benefits that might help to overcome these barriers. And we took this, as I also already mentioned, from a cross-national perspective. We were focusing on 4 countries, on Germany, Switzerland, Spain, and Norway, representing very different climate conditions, but also very different market conditions. And as we are part of the RACHP project, we did not only talk about heat pumps in general, but just went also focused on some issues like natural refrigerants, solar ice, and regeneration issues. The research we did, we started with literature review, which is not so much surprising. We are social scientists. We're just looking what others have done. And then we had a survey, but not a quantitative survey, but they have asked particular experts in each country with qualitative methodology, and then collected these results and then fed them back to national stakeholder workshops to have these findings validated and to enriched and to improve, and also to develop some conclusions together with these stakeholders. The first thing I think it's important that is to make a difference between what one calls social acceptance, which is acceptance in the broader public, and market acceptance, which is referring to the needs of different market actors. And market actors might be planners, might be building owners, might be manufacturers, but also those you would say that these are middle actors. These are plumbers, heating installers, which are very important to keep the energy transition going, to tap the potential which is there in the technology which is developed in research projects like RACHP. So we did interviews, and I think it's important to keep in mind, we started, a starting cell project started in 2019. We did the interviews in 2020. It was during COVID, but before the energy crisis, before that rise of energy prices we saw in the last year. So we did it in the 4 countries, and we also asked representatives from different stakeholder groups and collected lots of information from these interviews, and I will only give you some a short glimpse of some results. One is, of course, we have different categories of barriers and incentives. Not too much surprising, economic financials are very important. They are investment in upfront costs of heat pumps, which are more expensive than conventional fossil technology. But we have also issues on issues of public funding and support. And also what this comes with very important from the side of the middle actors is practical feasibility of installation and maintenance as an important issue for market acceptance. And this relates closely to the issue of competence and skills of those who plan, who and implement these technologies. And I will only focus on, we closely looked at different actor groups, only on the stakeholder group of heating installers. They are important not only because they they install the heating system, the heat pumps, but also because they are very closely linked to end users. They are advisors to end users. They are those who are usually in contact with decision makers on heatings, but they have only poor knowledge on heating, on heat pump and heat pump technology, because their expertise, their routines, is still rooted in the past, which is based on fossil systems. So they are not looking forward, but they just stick to the past. And as we see now, there's a really very rapid market, and they have low incentive to acquire additional knowledge because their business is still running very good, and so they can earn money, and they don't have an incentive to change. A second point, which is also by Armin or in the further presentation, what are stakeholders thinking about natural refrigerants? And we have on the one hand a couple of topics which are related to safety risks. Well, there are risks of certain natural refrigerants, but they are considered to be rather low because we know how to handle them. We know what to do. We have existing standards and regulations that can be applied. We know how to maintain, we know how to install. I think this was also Raphael told you what type of knowledge, of skills, and of practical issues are important there. But all these require appropriate skills and higher effort for installation. And think about the plumber, think about the installer. They are those who have to be convinced that these technologies are easy to handle. And on the other hand, we found statements around what are benefits of natural refrigerants, that they, of course, we say that high global warming potential, or also the ozone depletion potential of synthetic refrigerant is not sustainable. And this is a threat to the acceptance of heat pumps as part of the energy transition. But if you say this is all technology that is not sustainable, then that can be a risk to further deployment of heat pumps. And the second strand was about what Armin said, is good for the climate, always good for the environment? Because there are also some issues, some implications that might be harmful to the environment, which is result from new types of synthetic refrigerants. And on the other side, we heard that higher efficiency of natural refrigerants is a benefit, and also that they can be considered as a long-term solution. You don't have surprises in the future, but you know what you have now. But again, only little knowledge on natural refrigerants among many stakeholders. Also here, that is a huge important to share knowledge, to provide knowledge about these technologies, about their implications to the environment. This was the results from the interviews. We then had in June 21 4 national stakeholder workshops to feedback these results from the interviews we did. And in the first part of the workshops, technical results of 3HP were presented, and then we presented some of the findings of the stakeholder interviews and asked the participants of these workshops to rate what are the most important barriers from your opinion, and also what might be solutions that they could imagine to overcome these barriers. So we've seen overall challenges that were named were investment in upfront costs, shortage of skilled workers, and high planning and coordination efforts, especially in existing buildings. And among suggestions for solutions would be consideration of economic efficiency over the entire life cycle, not only look at upfront costs, but also to the entire life cycle, more support for new business models, such as energy contracting or new finance schemes, or also new finance and funding schemes, and very important, simplifying systems and providing easy-to-use planning tools to apply heat pumps properly in buildings. And again, we learned that key actors to drive to those two solutions are building owners, are heating installers, are planners, which we could consider as these middle actors, which are important. So finally, come to the conclusion. I see now we see this rapid market uptake of heat pumps has to address hindrances of key market actors and needs more policy support. I think an important issue in many European countries is lack of skills with installers, which might be addressed through structured training programs, which addresses different needs in different member states, but should also foster natural refrigerants requiring additional safety measures in comparison to traditional ones. You see the example of Germany, which Sabrina mentioned, that you get higher funding if you apply for natural refrigerants in heat pumps to cover these extra efforts, but also for heat pumps in general to have new business model to better support market penetration, and also have a clear roadmap for phase out of fossil-based boilers. And we also heard something about eco-design energy labeling, which might also be important to improve the market acceptance of heating and cooling systems. And finally, and not the least important issue is awareness raising of the benefits of heat pumps, and in particular heat pumps with natural refrigerant among stakeholders, but also among the general public. Thank you.
Thanks, Emmanuel. You can take a seat. So we have finished the round of presentations. No, you're not the only one. I'm just, you're here already. I would ask the presenters, please, to come to the... So we will have a Q&A session. We are exactly on time. That's very good. So, yeah, please, if you have any questions, raise your hand. I will try to moderate this. Don't tell me you don't have questions. Come on. No questions? I can ask technical questions, but then it might not be of interest. Jasper, do you have... Hello,
everyone. So again, I'm Jasper van Mout, Policy and Project Officer at Riva. You've heard me talk today a bit already. So I have a question on the, I guess, regarding what, and maybe this is more directed towards Armin and Raphael. In what types of applications for heat pumps do you see the biggest obstacles to switch to natural refrigerants? So I'm talking about air-to-air, hydronic, the size-wise. So where do you see the largest barriers, and what do you see on how that could be overcome on the long term?
When it comes to the different fluids, I mean, we need to see which fluid fits best for the application, and what is the real application. Is it just heating up a building or cooling a building? Is different than heating up water, for example, for tap water, which should be heated up to a relatively high temperature to avoid all these Legionella issues and all this stuff. So we need to see what kind of technology fits, and also at which part or region of Europe we are. And first of all, we should also always focus on charge reduction, meaning low charge refrigerants in the system. That helps always with safety issues. And as we see with some of these parallel projects, like the one driven by Fraunhofer, where they look at 150 grams of hydrocarbon, how many kilowatts, up to 12, if I remember correctly, you can provide. 12 kilowatt is more than enough for an apartment or flat and so on. So it is possible. Technology-wise, we can deliver, we can help vendors, and you see the large number you have shown on potential suppliers for these kind of systems. Yes, they have all a solution if you ask. And if the end user is aware of the challenges with the fluids, they are buying without knowing how the battery went. If the end user has the choice and is given the information, the broad information, all these environmental issues related to what's inside the system, they will do the right decision. I'm quite confident. Please, Raphael.
I would add on a very practical level, the two questions I would get as a manufacturer is, in terms of hydrocarbons, I have to lay the ground that so many products are available, and most of the applications, as we heard, are covered. There are some slots. So one question I would get is indoor installation, indoor air applications with propane. That is a little tricky. What I experienced in the last 20 years is we always underestimate the technical solutions available. We don't see them, and sometimes we don't believe that they exist, but that's what we are here for, to make things better, more efficient, to find the solutions. And they are there. They have always been found, and normally much faster than we would expect. We saw some examples. That's the hydrocarbon thing. And on CO2, I would get the question, but it's not efficient. So what I think is the challenge is to scale our view a bit and not just think about the very middle part, the process, and kill CO2, but think about the system, think about reliability. So the guy I mentioned, I talked to last week, he says they sell their units because they're very reliable. Efficiency has increased, again, because technology really evolves. They have found amazing solutions with ejectors that increase efficiency by 15%. So there's solutions available, but we need to think of the system, the hydraulic, the controls, and there's much out there.
Yes, definitely. And safety is first, always, and we can mitigate this. As you can see in other sectors, like the public transport, it has been decided by German railway that they go for propane in their next generation of air conditioning system for trains. This is also a nice, interesting movement. I mean, even if you can do the risk assessment for this kind of public transport, which includes tunnels and railway stations, and go with this kind of commitment, that's that's a strong message, I would say. Yes, maybe another question or comment, or yes, please.
I'm actually, my name is Davide Sabadiamos. I'll be speaking later at the second session, but I was wondering about the kind of practicalities and, let's say, worries or concerns of consumers that they came out in your research. I suppose noise, for instance, is one of these issues. I'd like to know a little bit more, if you can go into details about that. And also like to know from all of the participants, and actually from all of the panelists, if they believe that, I mean, it's going to be a topic throughout the whole event, but I mean, their opinion on the achievement of the REPowerEU targets, given the fact that we're looking at a more ambitious F-gas regulation. I mean, if they think this is going to be something that will kind of help or kind of sink the idea of reaching the number of heat pumps we have to reach in the REPowerEU. I mean, we're going to discuss this later, but I mean, I'd like to also hear your opinion.
Okay, thank you. I mean, if my start, I think it's important, as RACHP is focusing on multifamily buildings as a field of application, we did not talk to consumers in the sense of single-family homeowners, but we had more professional building owners or representatives of companies, which we talked to. And what we learned from them is that they are risk aware. So if there's something which is new and it doesn't seem to be proved, then they might not evaluate it further, but you can say we stick to the solution we know. So it is very important to have examples that show this type of technology works, and also to have good quality in installation and maintenance, so that those benefits you showed, COP of 5 and more, are really achieved in practice. So you need this type of quality assurance, you need this type of good, trained, well-trained installers to do the planning and the installation properly. And I think this is a very important point to increase acceptance, because if this don't work, we had, I think it was in the 2010s, 2012, I think it was in Germany also, that there was an increase in heat pumps. Large, say that they are very efficient, and then they turned out that this does not work. And this laid back the acceptance of heat pumps for a couple of years, because consumers learned that they are not as efficient as they are supposed to be, and then they've kept away from this technology. So it's really, really important issue, not only to look at numbers, but also to look at quality.
Okay, I start with the second part. So about the REPowerEU, personally, of course, we are pro an ambitious policy that help the market, help to speed up the market. But it's not my opinion. At the end, I'm a statistician. I only read the number. But what emerged from the interview with manufacturers, they are very optimistic, and they want the policy that help them to scale up the market. So this was the feeling in talking with manufacturers that already are in the sector with heat pump with natural refrigerants. So I'm very positive on the policy of the European Union.
I guess the bottleneck at the end of the day is the people able to install this kind of equipment. I mean, we need to retrain traditional boiler service people towards heat pump, and that is all across Europe. And this will be a major task in the next years, and also this is why where governments can help support vendors and organizations in creating these opportunities for training and fund also this kind of activities, because that will be the key, that we have experts at at all levels, from the design to the implementation, to help in this transition. Industry will ramp up production as they did on commercial CO2 refrigeration system. Once they changed to double shift, producing double the number of compressors and so on. So it's going. Industry will always adapt to the market, but we need to find these bottlenecks and help to widen these. Yeah.
So, last comment, hopefully. But no worries. So, for us as a manufacturer, we have the great opportunity because numbers are exploding. We know that we have a lot to roll out, and we have the opportunity to plan accordingly. Some of us have to enlarge their capacities. It's not only shifts, but some have to build, to have new production lines. And this is the opportunity to switch if we have to do it anyway.
Thanks. More questions?
Yes, actually we have, sorry Tim for the improvisation, but we actually have questions from the online audience.
Okay.
So if you want, I can read them to you.
Yes.
Yeah, sure. Right. So question from Thomas Novak. So I'll explain it to you later, but Thomas is joining us online, is following us online and is following the discussions. So a question to all presenters so far. Do you agree that heat pump technology should be favored over gas boilers by all means? And hence, should the first focus not be to get rid of fossil boilers, correct? To all presenters.
Yes. Yes, by sustainable heat pumps, Thomas.
Yeah, I think we all agree on this, right?
Okay, the answer is clear, yes. So then a second question by Nino Nenchev. Are there any renewable sources of CO2 currently in use for refrigeration, and are there any practical methods of capturing and reusing CO2 refrigerant from decommissioned systems?
Well, it doesn't make really economic sense to recover a few hundred kilos. So if you have a large system, if you have a small system, it's a few hundred. It's in a supermarket, it's maybe 100 kilos or something like that. Recovery in the global sense makes no economic sense. But when it comes to production, and we see a ramp up in Norway, they're building up infrastructure now to capture CO2, millions of tons, which will be re-injected in old oil fields. So a tiny part of this fits for all refrigeration application across Europe. So it's not an issue on getting these kind of fluids. And the good thing is also all across the world, natural working fluids are locally available. So nobody needs to spend hard foreign money in countries with low income to kind of buy these substances they want to get rid of afterwards. So that's also a good story on that part. And if we help them to implement this kind of system, leapfrog from the ozone depletion substances straight to natural working fluid, we really do a good job, I would say. That's why we help our friends in India and else to go straight from something which depleted ozone to CO2 and hydrocarbons and ammonia and water and air. Yeah.
So I know for us in Switzerland, we get our CO2 that we fill in the heat pump. We get it as a byproduct of a chemical plant, and then it's refined. It's used for our beverages, for many applications, and instead of releasing it, we put it into a heat pump. And it really is a question of quantity. So even if we have a supermarket system, as you mentioned, 300 kilos, many of us would release more CO2 in a year driving.
Okay, we have a third question from the online audience.
Yeah, go ahead.
Yeah. So from Victor Olen, thank you for the good presentations. One tough application regarding natural refrigerant is what to do with installed variable refrigerant flows systems. What is your recommendation for those?
Is it these VRC systems in the buildings? Is it the VRC system in the buildings where you have multi-indoor units and some outdoor units? I guess he's referring to that. I think we will see some of the leading manufacturers in this segment do have applications with natural working fluids, and we will see some. I showed some other innovative concepts where you can utilize a water system is also possible. It depends on the different projects, and it is possible to find a natural solution even for this project, I'm pretty sure. Somebody wants to comment on VRC?
I should not say something.
Oh, it's possible. Yes, please.
Yeah.
No, no.
Is there any more question? We are actually, that should be time to finish, but I think we can allow last question if someone now. No?
All this debate, and the important thing is that there is no magic fluid down the road. I mean, we should stick to what we know from the past, what we can utilize, and companies should not spend any research money in trying to find the magic fluid which is based on some F-gases. I mean, we can really cover all the different parts, focus on energy efficiency and safety of these units, and then we can spearhead, we can help our European industry to come back to the forefront. Otherwise, we risk that our friends from sending balloons and other stuff, they will take over the market. Look at cars. This is the same will happen in this sector if we are not doing the innovation ourselves and help our market and create it in Europe.
So, thanks, panelists and presenters, and thanks all of you. So we have a coffee break now, and then we start the next session.
I hope if I'm speaking here that I get the attention of people outside as well, because we are going to start in a few minutes, I'd say 1 to 2 minutes. So yeah, if people could sit down. I see it doesn't work as well as with the first session. Maybe I should just go outside and shout. All right, I think we can start the second session after a very fruitful and nice first session. So this part will focus more on the phase down of F-gases in heat pumps in the context of the F-gas regulation, so more towards the policy debates on the F-gas regulation. I won't go into too much detail with the agendas, which you can see here on your screen, and you might also have received it in the front, and it's all the agendas are on the tables as well. So basically, we try to bring a nice balance of speakers in terms of EU institutions representation and research and associations. At the end, we will have a panel discussion. So one small thing that changed regarding the panel discussion, you might have seen it online. There was a last-minute change. So Thomas Novak unfortunately couldn't make it due to unforeseen circumstances, but we've seen that he's following us online. So yeah, so we're very happy with that. And he's replaced by Hilde Dont. So thank you again, Hilde, for the last-minute jumping in. We're very happy with that. Who is a task force member on the refrigeration task force at EHPA, and also department manager at Daikin Europe. So yeah, you didn't come here to hear me speak, right? So we'll have the first speaker, which is Arno Kaschel, policy officer at DJ Klima, on behalf of the European Commission, who has the people that have followed the F-gas regulation debates in the past years will certainly know him, as he's been facilitating and coordinating discussions within the institutions and with stakeholders. So Arno, I will give the floor to you.
Okay, thank you, and good afternoon. And I've seen a lot of people I've seen in the audience before, so maybe I will not be showing a lot of new things to you, but I was asked to give a short introduction to the proposal of the Commission on the F-gas regulation from, I believe, almost a year ago in April. We've made it, and also maybe a little bit on what's going on at the moment. I don't want to, of course, go too much into that because we have other speakers that can do so, for instance, on the Parliament side. So a bit the frame around this. Internationally, it's of course the Montreal Protocol that originally addressed only the ozone hole recovery, but in the Kigali Amendment that was agreed in 2016 and applies from 2019, also greenhouse gases were added, the HFCs, because they are replacing ozone-depleting substances for the most part. So this is a bit the international obligations that as EU we have, and we have to follow, and we want to do this, of course, because as you can see, there's also, I don't know if the laser works, maybe not. You can, by reducing these HFCs, you can save up to 0.4 degrees Celsius, 0.3 to 0.5, I think is the latest what the scientists tell us. So that's quite a bit. And that comes on top of savings from the Montreal Protocol that have saved or will save up to 2070, 2 degrees in additional warming. So imagine without the protocol, we would be in much bigger trouble than we are at the moment even. So the F-gas regulation is a bit the EU's way of implementing it, and we have been early players in this. We, with our latest, the one that's in place now, we came before the Kigali Amendment and we helped it come about. So we've always been kind of showing the way to others what to do, how to reduce these gases where we can, and that's a little bit also what we want to do this time around. A number, we don't have to read through all of them, but the existing F-gas regulation has been recognized or is recognized as having been quite successful. And actually, I'd like to quote actually what our industry has been saying down there, things that we did pick up on in their communication. So quite something to hear from your industry, and you see the numbers in demand, in imported equipment, emissions dropping. So there was a lot of progress in a relatively short time. The 2015-19 is the ones we looked at when we prepared the new regulation, because we started in 2020 doing this exercise. And you see also that it has been a driver for innovation. You see here, these are some data from, I think, Atmosphere mostly, that especially in refrigeration, we have advanced quite a bit in these years. Oops, that was a bit quick. So what are we proposing now? You see here in the letters what our objectives are. One main point is, of course, under the Green Deal is the ambition to go quite quickly, quite far, quite quickly, and end up in carbon neutrality, in climate neutrality in 2050. And that also means that in this sector we want to do more. And the main way to do this is by making the quota system stricter. The quota system has been an incentive to push across the board for alternatives to be adopted, because this way you don't need to use HFCs and you can save on your quota. And also alongside this quota system, or what we call it the phase down, add prohibitions in different sectors where we could cover 100% or near 100% of equipment with alternatives. And in order basically to give a stop sign for these easy sectors, here you have to be out by a certain date with a certain GWP limit, and then that would free up quota in other sectors. So that has been the approach. It has worked quite well. So that's kind of the same approach, but with a tougher quota system and a couple of new prohibitions. We need to make sure that, this is point B, we need to comply. We can comply in the long run with the Montreal Protocol. That means we have to do a couple of changes. In yellow, you see remove some exemptions, in particular the asthma sprays. The metered-dose inhalers is one thing that's not exempted under the Montreal Protocol, and we have alternatives there. This is why also in this sector we think we can do better than the status quo, where we're basically using HFCs across the board. And then the point C is something that has been quite important to industry also, because there there are clear indications that there are illegal activities to a degree that we don't want to have. And so there is a number of improvements in the proposal of making the custom rules and the market surveillance rules stricter, having more how to put it, harmonized is maybe a strong word, standardized, I say here, penalties that are more effective in preventing people from incentivizing people to not engage in these illegal activities. A quota price to also keep only those players in the system that really should be there, and the certification of technicians, which has been from, I think, all across industry, from the technicians themselves to the manufacturers to the end users, has been a call for more in order to also address alternatives and training on alternatives. So those were the changes in a very helicopter view that we've made, and I've picked out the ones, of course, that are most relevant to the heat pump sector here, and I'm sure you have seen them. So there is relatively early, in 2 and 4 years' time, depending if it's rather on the self-contained or in the split systems, that you move to a GWP of below 150, and for the larger than 12 kilowatts, it's the GWP was set at 750. And those bands should not be seen in isolation. They are clear signals, that's why they're there. But there's also a strict phase down that also in many other sectors pushes for more innovation and moving out of HFCs and into alternatives below 150 very quickly. So what do we like to achieve? And you see that in our impact assessment, we can have savings of 310 million tons on top of the 420 that the current regulation will achieve. And we will have in 2050 emissions of 14 million tons. So that's down from near 100 tons that we've had not too far away. And so that's very close to climate neutrality there. This is a sector where in many subsectors you can have energy savings because of you're putting energy efficient equipment into use, and this is why also our abatement costs are often low or even negative. So that's actually compared to other sectors a very good, maybe for the industry in this sector not good news, but it is a sector where you can do a lot more things. And yes, green innovation and growth and reducing HFC use is, of course, something we want to achieve. Maybe a few words. You see, it's maybe hard to read, but in this honeycomb, you see those are different measures to help us achieve the minus 55% in 2030 and the climate neutrality in 2050. And there's lots of them, and the F-gas is one of these puzzle pieces in the end. And it is also helps because it's not regulated by the emission trading system. It's under the effort sharing regulation where member states have to contribute, and any savings that are made by the F-gas regulation helps member states achieve their rather ambitious targets in this regulation. So that's how it connects to the larger climate picture. And also, of course, there is this link to heat pumps that's been quite often pointed out. And our energy policies, be it renewable energies, energy efficiency, or buildings. So there is quite a good link, and that's why I wanted to address this issue, because it's always been claimed that the F-gas regulation is not in line with Repower EU. We think it is fully in line with what Repower EU wants to achieve, and it's also been double-checked in our analysis that that's the case. So, of course, we need a lot of heat pumps, that's clear, which is a huge opportunity for the sector. And the ask is here that when we make these new production capacities, we look towards the future and use the alternatives that would also reduce our direct emissions, which in the future are becoming more important. When you have green energy, then in the end your direct emissions, they are even more relevant. So what we we see that in the heat pumps, for instance, that the technology is there, so we would like to adopt it now before others do it and roll out our market. So that's a clear signal to the European industry in order also to give them a business case in the longer run, and that also should be seen at world level where, you know, under the Montreal Protocol, all countries need to move out of this. And a lot of developing countries, for instance, are looking at the propane technologies in the heat pumps, just to make it plain. As I said, we have checked, do we have enough quota? We did check it. We checked how much extra demand of HFCs we need for the heat pumps for REPowerEU that still use HFCs. And we have enough in the quota system to account for this as proposed. And the idea is not to lock in these emissions for a decade or 2 decades if we put equipment with HFCs into place in cases where we would have alternative equipment already, which also benefits in the end user, as I said, due to energy savings. And just maybe last slide, a few words on where we are now. It is between the European Parliament and the Council, that's the member states, to discuss this further. And the Council has had many meetings, I don't know where we are now, maybe 7 sessions or so. And they are working on a joint position in order to then talk to the Parliament. The Parliament, you see the timeline here, and maybe the speaker from the Parliament later can elaborate. We expect Parliament to vote in plenary in April, and that's also, I understand, the timeline a bit for the Council to have their position. So we could, if all goes well, in May or June, have the trilogues when the Parliament and the Council sit together, and the Commission is also present as an honest broker, and then hopefully agree before the summer a new law. And that would then mean that it could apply from the 1st of January 2024, which is our aim. It still is possible, but we cannot delay this timeline very much as the one we're running with at the moment. So far, it is hard to see where we will land. And there is both in Council and Parliament still different views on different items. So it is still, I think, an interesting discussion. So far I think we're engaged everywhere and trying to, as Commission, make the point, what is possible, what is not, in order to have then a law that's ambitious but also feasible at the end of the day. So that would be it from my side. I don't know if there are questions. I guess you would invite. Hand over to you.
Yeah, I would. So indeed, we have a few minutes for questions. Are there any questions on the F-gas regulation revision? This is the perfect timing to ask about the timeline. No questions on the floor? Yeah. Okay.
Alexander Rolat, Mitsubishi Electric. My question, Arno, is the timeline that you would prefer to have the trilogue agreement by the end of the summer. We'd then have a process with all the translations, etc. So would you say for that timeline, publication in the official journal sometime in September?
Well, we certainly would have to agree before the summer. And then, yes, and then we would have to make sure, as you say, lawyer linguists and all that, to make that fit. It is still tight, but still possible. So that's what we're working on.
Okay, and if agreement isn't found before the summer, at what point will the Commission, as the honest broker, say, actually, the 1st of January 2024 for the first phase down step is unachievable?
Well, if
September, October, November, December?
If we don't reach agreement under the Swedish presidency, which ends end of June, I don't think we can start on the 1st of January 2024.
Okay, thank you for the honest answer.
Okay, thank you. Any other questions? And indeed, when you ask a question, say your name and the organization you belong to. Any other questions? It was a very clear presentation, of course. No? Okay.
I would actually have one question, because we had in a previous presentation a discussion about the definition of the global warming potential, to include also the LCA in this definition. Do you think, is there any chance for doing that in the new F-gas regulation?
The SCA.
The LCA, the life cycle assessment. So for the moment, the cost or the environmental effects of different refrigerants are not included from the production until disposal and all the decomposition products.
Yeah. Well, life cycle assessment is always a very complex, comprehensive exercise, and you know, different methodologies and different people arrive at different results. So that's always something that I have personally looked at critically, because it's, you know, difficult to establish what is what. So we look at the climate effects, most importantly, but of course there is a larger issue also lurking, which is environmental effects. But that is something that is being looked at in great detail under REACH, and I think we're very close from having the first idea about how that may look like. So that's not something we have been able to address fully in the F-gas regulation, if you think about environmental effects.
Thank you very much for your answer.
Okay, Hilde.
Hi Arno, I'm not sure if you are staying until the panel discussion, so I'll pitch it now. You refer to Repower EU and 30 million extra heat pumps by 2030. As European Heat Pump Association, for which I'm speaking here today, we estimate that the growth of the heat pumps is much more than that. It's actually 60 million heat pumps by 2030, because we are also counting on the air-to-air type heat pumps. And these are currently, I think the atmosphere lady has shown it, 40% of the EU market. In some countries like Finland, it's 80% of the heat pump market. And we have not seen in the Commission assessment for the F-gas review any analysis of what the air-to-air heat pump market needs. So we would like to have a further discussion with the Commission and the legislators on that later on. Thank you.
Okay, I can already comment. Yes, EHPA has very large numbers, and hopefully we will reach those. But on this analysis that we've done, and we've shared that with the co-legislators, we use the numbers from EHPA that were given to DG Energy as for our analysis. So that would be then even more than what the Commission assumed under the Repower. So.
This is an interesting debate, and I just have a clarifying question. For the numbers that you guys have ginned up, does that include reversible heat pumps? Yeah, but reversible for air conditioning as well? Yeah. Okay, so isn't that considered air conditioning under the F-gas regulation, just to understand a little bit?
Air conditioning is a very wide term, and it includes everything.
Yeah, and I was just saying, because I was under the impression heat pumps was implying heating only. And then when you went to the reversible heat pumps AC, those tended to be categorized under air conditioning. So just wanted to try and clarify that.
Maybe the numbers are a little bit higher, because by 2030 we'll have also the 3 HP heat pumps with natural refrigerants on the market.
Hello, Christoph from Teneo Consultancy. You mentioned the numbers that, and again, the impact assessment that shows that the phase down is in line with Repower, and this is possible. And again, even giving the numbers, 30 million numbers that we're talking about. Has the Commission made any calculations, any analysis into what would happen if some of the amendments that are currently tabled in ENVI would pass? Basically adding extra bans on the per individual use cases, either by excluding all HFCs or by putting the GWP numbers so low that basically no HFCs could comply with this. Have you made any analysis? Have you submitted this to the European Parliament, or is that not something you're looking into at the moment? Thank you.
So I think there's 680 amendments in ENVI only, and there's a lot in ITRE too. So we haven't analyzed every amendment, especially not when we think it doesn't fly in the end. But we are, of course, looking at things that are likely to be retained. And yes, we're doing the analysis where we think that is useful, and you are fully correct. If you move bands, this may have a bearing on the phase down. So we are not, if you remove exemptions on the quota system, or if you add bands, this you should then compensate somehow in the phase, and that would be the rational thing to do. And where we have clarity in this process, we will of course make these calculations to propose it to the co-legislators, because we're not in the driving seat. But we can make the point, that if you move a ban by year, this will have so and so many tons CO2 equivalent that should be added to the quota system. That's certainly something we would be contributing to the discussion, yes.
Okay, I think we have time for a last question. Davide, you had a question?
Coming back again on the GWP thing, because though I reckon that LCA is tricky, it's like a mom, everybody's got the best mom, so everybody's got the best LCA, but it is true that we have new GWP values from the IPCC, and the latest IPCC, that you have not taken into consideration. I'd like you to remind us, because remember that I heard from you, what is the technical reason why the Commission didn't adopt the new real GWP that is there, but only kept the previous ones, and also why did the Commission maybe didn't directly go to the GWP that is actually considered in the 20 years instead of the 100 year, because that's what really counts, what we do in the next 20 years to prevent climate crisis.
Okay, so. Of course, GWP 100 years is chosen as a metric, so you can compare lots of different things. Some gases that live, so to speak, in the atmosphere for thousands of years, and others that only live a few months in the atmosphere. So you compare it on a certain basis, and depending on how long your species lives in the atmosphere, one is more relevant than the other. But of course, the GW100 is the one that's accepted as a comparison, and in the IGALI amendment of the Montreal Protocol, we use the assessment report 4 for the HFCs, and we wanted to be as comparable to our obligations as we can. That's why we didn't change this to a more recent numbering. We have in the regulation a delegated act as Commission to change if this is adopted elsewhere. So if the Montreal Protocol would change in the near future, I don't see it, but if they did, we could change it. And we did this for the HFCs only, because they are the ones regulated by the Montreal Protocol. For the other fluorinated gases in the regulation, we went to the assessment report 6 in order to exactly do what you said, update with the more recent figures, where we didn't have this obligation tied to the Montreal Protocol. So we did it there. In addition, we added the GWP 20 for information only, but just to show people, as you say, for the public, that some gases, their GWP 100 may seem rather low, but on a 20-year basis, it's higher because they have a lifetime of 16 years, for instance, if I'm talking about a particular species. So it is there in the regulation. It's not tied to any of the obligations, but it's there and in order to emphasize the point that, yes, some of these species actually they're more relevant than we think they are, just because we always talk about the GWP 100 for them. So we did a number of things, just also keeping the constraint of the Montreal Protocol obligations in mind. That's why we didn't update, so to speak, the HFCs.
Okay, thank you very much. We are running out of time. I'm very sorry, because we're running behind schedule already. But if I understood correctly, you're here until 6 o'clock, so we can involve you in the panel discussion if there are questions, if it comes up in the debate again, so we can address it then. But thank you so much for the presentation and answering the questions.
Okay. Thank you.
So our next speaker is Kęstutis Kupstis, who is the rapporteur of the on behalf of the European Economic and Social Committee, who will shine a light on the perspective of the civil organized civil society, I won't talk for too long. The floor is yours, Kęstutis.
Thank you so much. Thank you. It's a pleasure to be here, and my pleasure to represent the committee. I know that perhaps not everyone is aware of us. You don't hear too often about the Economic and Social Committee, so allow me to start by introducing ourselves. And we are a consultative body, and we are established by the treaties, so we are part of the institutional landscape. We do represent organized civil society, and what does that mean? So we have groups and organizations in our committee organized in 3 different segments or groups. We call them groups. Number 1, employers. So it's usually when you know very well. Most of you are possibly also part of those umbrella organizations, Business Europe, employers, federations, chambers of commerce, and so on. Then the next group is trade unions, also quite homogeneous group. And the third group, to which I also belong, is civil society organizations group. So essentially it is all about the rest, all about the professions which are organized differently. So we talk about NGOs. I come from consumer organization. My organization which delegated me to that body is Lithuanian Consumers Alliance, and we are part of the BEUC, the European Consumers Organization. So I come from consumers' rights advocate side. But there are also so many others, farmers, environmentalists, liberal professions. So we are, really quite varied group of people organized in this group number 3. So we all come as individuals to the committee, but our mandate is to defend general European interest. We are selected by our governments. There is usually a selection procedure. I had to go through, like 3-stage beauty show until I got the nomination. And it was quite difficult to achieve. But in the end, it is governments who suggest candidates to the council. The council then approves our nomination, and voila, 329 people strong committee is here at your service as an advisory body. So we got this dossier on our table. We have to produce an opinion on the F-gas regulation revision. And that was back in 2022. So our opinion is something like this. Yeah, it's just 7 pages long. There are strict character requirements. It cannot be too long. So I invite you all to read it. It will only consume a little bit of your time, but you may probably get some insights. So our, let's say, key points from that are summarized here on the screen. And, well, I will not talk about that at length. You see it on the screen, and you probably, you are professionals in the field, so you grasp the meaning straight from reading those lines. Simply, we see space for more ambition, first of all. That's how our opinion comes straight after the proposal. Yeah? We disseminate that opinion to co-legislators, and that also sometimes serves as an inspiration in future debate, in future negotiation process. And we think that there is an additional opportunity to raise that ambition by focusing on how to enable low GWP value refrigerants to be used more widely. And especially when it comes to heat pumps, we say that for segments, for certain equipment where it's possible to use very low GWP alternatives, these should be promoted by imposing a sectoral ban as a very clear, very straightforward measure. How come we have 2030 here? It was quite an interesting debate during our work. Our industry colleagues, from the business perspective, from the group number 1, where we have employers, came with a suggestion that, okay, we are fine with this wording, but let's push it as much as possible forward, 2035. And it was a matter of compromise. So the committee is famous for this compromise search, and we are a platform where we strive to get compromise between different groups. So we have 2030 here, and still, I mean, it is a clear position of having a ban on all refrigerants for heat pumps and other equipment where you have alternatives, where you have technical capabilities, and we see that it is indeed a great opportunity to combine with the Repower EU, because we don't want new dependencies. We are already dependent, and in light of the European strategic autonomy, search for that autonomy, we should essentially build European industry base at the, using the latest, most advanced technology with least polluting, least climate damaging refrigerants. So there are, of course, there are fears of the market bottleneck, but I believe that if a political signal is sent, very clearly sent to the market, then essentially everybody can quickly reorient and go straight to the right point instead of going around for ages. So we believe that this could also be an exemplary case of this Brussels effect of putting global standards for green transition forward. So we see also some room to have a mechanism how to collect more money from quota sales. Essentially, we have to impose higher prices, higher tariffs on this. I know the reasoning why this is not called the tax and so on. It's a little bit of a play here, a little bit of a game. But essentially, if we get enough money from this, then we are able to support training alternatives. Also, essentially support customs training to have effective fight against contraband of high GWP substances. So my last point is essentially also a little bit of a, let's say, a provocation for you here in the room. That's what I got simply by searching for clues how natural refrigerants are promoted, or in a sense how the training is organized. What kind of visuals do we use? And I know that some of you in the audience may like this picture and others may not like this. So let's discuss it perhaps. But to my eye, this is not the most attractive way to organize these things, right? So if you want, I don't know, if you promote your dinosaur park or something, maybe a very hot food, perhaps, for your restaurant, then probably you might use something like this for those connoisseurs of, very sharp tastes. But maybe this is not the best, not the most attractive one. But I leave it here. And also, if you allow 1 minute for my observation based on what I heard earlier today on the discussion. Now, what what caught my mind was the question about possible CO2 removal from end-of-life equipment. Yeah, that was, if I understand correctly, one of the ideas. Like, how do we deal with 300 kilograms of CO2 at the end of life, of some equipment? Now I'm thinking, from the, let's say, from the perspective of internalization of some of those externalities. Yeah? Like if you talk about escaped HFCs as simply externality, which just happens. Yeah? We paid for the quota, we did everything right, we passed the issue to the consumer, and at the end of life, it's not our business, essentially. Let's be clear, let's be honest. It's not our business if we have escaping gases, if we have high escape rate, and if we have a lot of very damaging HFCs escaping to the atmosphere. Because, well, that's just happening, and that is, it's clear externality. Because we all pay, or essentially nobody pays for the escaped gas. It's in the atmosphere. We are not behind us. Yeah? We all feel the effects, but nobody pays for it. And then suddenly we are talking about an issue of escaping, of 300 kilograms or 20 kilograms of whatever escaping to the atmosphere. Now the thinking goes, and I present that as just an idea, or what if you think the other way around? Yeah? If you simply add the high cost of HFCs escaping, right, at the very beginning, and then that installer who cannot get the gases back is punished for that, in real terms, then the whole economic case for natural refrigerants would look very different. Huh? If you put 600 GWP, or you put 1 GWP, right, in your equipment, if it is internalized. So I think most of you get the point. And it might be a really different, let's say, mindset that is necessary to clearly make this internalization of real damaging effect of high GWP gases. Thank you for your attention. I hope I don't have too many questions, because that would probably ruin your agenda.
I think we should allow for some questions and comments, if that's okay by you. Are there, I can imagine there are certainly remarks on this, or comments, questions. Does anyone have any input? No? That does make it. Armin? Yes. Okay. Yeah.
I saw the Swedish one. Okay, let's do it. So mine doesn't work. So my name is Armin Hafner. I'm the professor in refrigeration in Norway. Norway has this in place, the taxation or the deposit on the fluid. The challenge nowadays is, it's based on GWP. So when you now utilize refrigerants, which by definition on a 100-year perspective and the real lifetime of 10 days have no GWP anymore, what is the incentive of the owner to do a proper recovery and return to a safe deposition place? That's the real challenge, the business case. So that's why we need to find a way between REACH and GWP to find a way to make this intensive, get this intensive back, to really recover and to deposit and bring it back where it belongs, to a safe place. Just a comment.
Yeah, I know it's just a comment, and indeed I cannot. I know you know better. You know the dossier probably better, because that's your everyday work, and we come only as an advisory from the civil society part of. Side. And to me, it's clear that the damage is done when it escapes. So the efforts should be about avoiding that escape and not getting so much initially, but to have the end of life.
And it helps. It helps. I mean, 404A is recovered heavily because it's so valuable to return it, and money helps, definitely.
Thank you very much. Okay, I think we need to go on to the next presentation. Thank you very much, Kęstutis. So, this is a small mix-up on my side. I'm very sorry. The next presenter is Michael Kaufeld, professor in refrigeration engineering at Karlsruhe University of Applied Sciences. As the title suggests, he has a lot of experience in refrigerants and is also the director of Steinbeis, which is a knowledge center that advises companies to make the switch to natural refrigerants.
Yes, among other things. Thanks a lot. Yes, let's see. Comparing the use of HFCs and HFOs. There you have the title again. This was from an investigation for the Environmental Investigation Agency, EIA, in 2012. And you can see how the emissions from the heat pump sector was expected to rise. But remember, this was 2012, and this is how the heat pump and the numbers of heat pumps looked like in 2012 from Statista. And you can see now we are in 2022 and the expected growth. So if the heat pumps would remain with HFCs, the HFC emissions would rise drastically from the heat pump sector. So we have to do something about it. Use low GWP fluids, and yeah, that's. This is the answer from the conventional refrigerant manufacturers, HFOs, because they decompose in the atmosphere very quick. And here have some examples. This 1234YF is the one which is used in your car air conditioner. If you have a newer car. And because they break down in the atmosphere so quickly, they have a very low GWP. But if you click down, there's a lot of text. Then you can see they form 4 to 5 times more trifluoridic acid than the HFCs they are replacing. It is not good. And they also do it much at a very local form. And the other thing is when they burn, it's not very nice. And also there are some studies suggesting that there might be health problems at high concentrations. So people working a lot with those fluids, they may experience some health issues. So this is my personal view on HFOs. You can start subtracting if you want, but that's not what I mean. It took 60 years from the 1930s, from the invention of the CFCs until they disappeared again due to the Montreal Protocol. And then it took 30 years to the F-gas regulation to get rid of the HFCs again. And I think it will take 15 years to get rid of the HFOs again because of this TFA issue. And then remember, that's what it's saying there in the title. I showed this slide the first time in 2017, so it's not 15 years from now, but 15 years from 2017. Some people, they say oh, how can you know, or how can we be so sure? Well, this is the conference poster we had in 1996, suggesting that the HFCs should disappear again, and everybody was shaking their head and saying this is not going to happen. In 1996 they were just introduced to the market, but now we see that they are phased out again. And I'm sure that the same thing will happen to the HFOs. And now the next 3 or 4 slides will show some arguments. These are some measurements in Germany. You can see the map of Germany to the right, and there were 8 different measuring sites. Trying to find out how much of TFA is in the atmosphere and in the rain, and compared to measurements from 1995-96, it's an increase by a factor of 3 to 5. And this is another study from Germany, from leaves of trees, showing that the TFA concentration in the leaves of the trees far away from any farming areas is increasing. So this can only come from the air. And this is the Rhine River, some measurements, and you can see how the TFA concentration in the Rhine River is increasing. And there are a lot of arguments from the refrigerant manufacturers that TFA is, there's so much TFA in the seawater. That might be right, but there's no TFA in the fresh water, in the sweet water usually. And here are some measurements from Switzerland. Switzerland, or most cities in Switzerland, get their drinking water from the lakes. And if you compare the two columns in lake water and in drinking water, it's almost the same amount, because there is no way to remove TFA again from the drinking water. The only way you can get rid of it is by reverse osmosis, which is used in some countries in the Mediterranean to get the drinking water from the seawater, but it's very energy intensive, so it's not something we want to have. Here you see the comparison between 134A to the left and 1234YF, and you can see that about 20% is converted to TFA from 134A, but 100% is converted to TFA when you go to 1234YF. And this was a simulation from British scientists. Because of the short atmospheric lifetime of the HFOs, whatever breakdown products you have in the atmosphere, they will occur locally. Like 134A has an atmospheric lifetime close to 10 years. So whatever you emit here in Brussels will decompose maybe in Antarctica or Australia, but not here. But this is completely different with the HFOs, because the atmospheric lifetime is 1 to 3 days. If you have a nice warm summer day without any wind, then all the TFA will decompose, or the HFO will decompose to TFA locally. And you can see what it does to the area around Stuttgart, Munich, Switzerland. You have about a 250 times increase in TFA concentration compared to what we had with 134A. Now, what can we do if those HFOs are no good as low GWP refrigerants? This was a study done by a former colleague of mine, Mark McClinton, and some of his colleagues at the National Institute of Standards and Technology. They used a chemical database with 60 million chemicals, and the conclusion was, after HFO, we have to go back to some of the previous generations, either CFCs or HFCs. HFOs are no good. Then what is left if you don't want to damage the ozone layer again, we don't want to increase the global warming, then we have to go back to the natural fluids. It could be ammonia for large industrial heat pumps. It's a perfect fluid. Could be CO2, for example, for heating of tap water, or it could be the hydrocarbons. And you can see there an advertisement from 1922. Propane was sold as the safety refrigerant compared to toxic refrigerants. And one of the things I think we have to do, we heard a little bit about training today, is we have to get the traditional plumber or heating installer used to work with gas furnaces to talk with the heat pump people. Because the heat pump people, they are used to non-flammable gases, whereas the traditional gas furnace installer is used to work with flammable fluids. So and those two have to exchange their knowledge, and then we have a lot of people who are able to install heat pumps, and we have a lot of heat pump installers who are not afraid of flammable gases anymore. And then water could also be, for high temperatures, a very nice fluid. There's another thing to look at, that's the CO2 equivalent emissions during the manufacturing. And if you look at, and those are the blue bars, if you look at 134A and 1234YF, the CO2 emissions are much higher than for the natural fluids. So that's another reason to go to the natural fluids. When it comes to efficiency, this is also from Mark McLinden and his colleagues. And I'm sorry, it's very small, but the important thing is up here at the top. The best fluid is ammonia. And that's also the reason why they're using ammonia in the International Space Station as a heat transfer fluid. If you go to a cycle with an internal heat exchanger, then the picture is slightly different, and you get propane and propene as the best fluids. So there's a good reason also in terms of energy efficiency to switch to the natural fluids. And this is also reflected in some seasonal COP numbers. This was a recent publication in the German magazine called CCI, where they had a long list of heat pump manufacturers for multifamily houses, for air-to-water heat pumps. And you can see at the top there are the HFC versions, and the seasonal COP for heating is lower than what you can achieve with propane, which are the two bottom heat pumps. And also the maximum temperature you can reach is much higher for the propane solution. So there's another reason to go to propane as a heat pump fluid. When it comes to safety, this is a very or rather old publication from 1999 from Switzerland. And to the left, you can see the number of dead people, 10 to the -4 with traffic accidents. And everybody accepts that. And you can see there the homeowner of a propane heat pump is 2 magnitudes lower. And when it comes to number of hurt people, also there the homeowner, the technician, the homeowner of the propane is not even shown because it's so low. And the homeowner of ammonia is also would be very low. Just one slide on the safety on the flammability. This was a study performed in Germany by Glenn Dimplex and a former student of mine, Holger König. They had a heat pump, a housing, an outdoor unit, and they charged the entire housing with the most flammable or most explosive mixture, and then ignited it. And there you can see the pictures, and there was no explosion. It was just burning a little bit, and the flame propagation was at the maximum 50 centimeters away from the housing, and no parts were flying around. So they said it's completely safe to use propane in a heat pump in an outdoor unit. And as we heard earlier today, you can also do it safe with the indoor unit, just have to make it with a ventilated cabinet. Or what you could also do, this is what they have from Fraunhofer, ISA in Germany. It's a heat pump with 150 gram charge, so that's the maximum charge for the household refrigerator. And they achieve 8 to 10 kilowatt or to 12 kilowatt even heating capacity. So this is enough for every single family house, and also well-insulated multifamily houses with 150 gram of propane. So to conclude, future heat pumps should use low GW fluids, but those should not be HFOs. And here's an example from the clothing, because we had this discussion before we started today, that there are many other sectors where they use these forever chemicals. And for impregnating clothing, they traditionally use those PFAs, but you can also do it with natural fluids. The refrigerant charge should be reduced quite a lot, and then you should reduce the greenhouse gas emissions, run on renewable energy. And what is very important, to my opinion, is this one. They utilize the waste heat from refrigeration and air conditioning systems. We have a very nice example in Karlsruhe. The tire manufacturer, he has a refrigeration system, 1.5 megawatt capacity. So they throw 2 megawatt of heating into the atmosphere in Karlsruhe, which could be used for the entire area around the tire manufacturing. And what we had as a topic in our RACHP, thermal energy storage, will also be very important for peak load shaving. Thank you very much.
Thank you, Michael. Since you're on the panel later today, we'll keep questions for you on the panel because we need to move on to the next speaker.
Or during the dinner.
But we will see Michael again later on the panel discussion.
During the dinner.
Or during the dinner, yes.
Every question, one beer.
Yes, indeed. So we try. I'm going to go back. Sorry, I have to go back to the slides. Because I made a mix-up with the slides. I'm very sorry about that. But I'm very honored to introduce our next speaker, who is Mr. Kim Propulo, who is a shadow rapporteur on behalf of the ENVI Committee in the European Parliament. He's extremely active on a lot of topics, and especially in recent months on the F-gas revision. So we are extremely honored to have you here today.
So, dear all, I'm very happy that I'm here before you, studying on this room. I'm declaring from the beginning that I'm not someone who is expert. You are the experts, but I'm from the position of politician. I want to say that I am quite ambitious, but also I'm a very logical person. So I feel very happy being here at this very multi-voice event on this radical time for the EU and our environmental commitments. We have the FIT for Fit for 55 package, which is closing, a deal. And I think that the revision of the F-gases regulation is one step further to the EU commitments of net zero emissions by 2050. We don't need this. We don't need to take something which is very valuable and has tremendous applications to be taken lightly. I was very every time that I was reading at the beginning of this file when allocated to me, it was great. It was I was surprised when I understand that F-gases are almost everywhere. So they have many applications in our lives, and therefore we need a holistic approach that focuses on technical feasibility, energy efficiency, and takes into account fast access to safe and reliable technologies, which is vital. It might have been heard also that the industry in some cases are divided and seems to be divided. From the beginning, when this file was allocated to me until today, I have heard too many different voices and was presented to too many different numbers. This is why today it is very important that we could hear and compare the different solutions, advantages and risks. Although my position now during the compromises might be slightly different from the amendments I tabled as a shadow rapporteur on behalf of my political group, EPP, I still believe that any transition should be safe. But let's think, what does safe mean? And what in this position is safe? We have evidence from different companies that heat pumps can move to natural refrigerants. However, heat pumps have many different applications. Different rated capacity can be air-to-air or hydronic. And this application will be used in 27 different countries with different climate, different heating and cooling needs. Therefore, we do want to support the transition towards the natural refrigerant, but we need to do this safely for our economy, but also for our citizens. Therefore, I believe that we need more time. The regulation will be published in 2024 and taking into consideration REPowerEU and the need to have energy efficiency independently from third countries, moving away from fossil fuels, we will need a huge supply of heat pumps in the next upcoming years. However, the production line cannot change from one day to another. Therefore, we say yes to complete transition to natural refrigerants where this is technically feasible, but giving the industry the appropriate time to adapt. During our negotiations, there are tough discussions, but I'm positive that we will find a compromise that best respects the environment and the EU targets while giving efficient time to the industries to adapt. This is where we are, and thank you very much for your attention.
Would you be open for, no? Would you be open for questions, or I know, because I know your time is limited. Are there any questions on the floor for Mr. Kimpopoulou? I can imagine there are at least some questions, right? No? It was very clear. Yeah, okay, yeah.
I didn't introduce myself last time I spoke. My name is Tim Grabia with the Environmental Investigation Agency. It's fantastic to see you here. Thank you for coming. I'm just curious about the dates which you have referenced and the speed. As I understand, the F-gas regulation contains a safety valve or a mechanism by which, under Article 11.4, exemptions can be made for specific categories of equipment and products that might sort of allow us to be ambitious, but then also nuanced, as you had previously spoken to. So I'd just like to get your thoughts on that mechanism and why that might not be adequate to support early dates.
As I said before, and I think this is my only concern when I'm talking about F-gases in general, heat pumps, is both to be safe for the people and to have the space in order to install the equipment. This is my only concern. If there was the possibility to have a wide variety which is applicable for where is applicable everywhere, I would right now to have this kind of opportunity. But think, we have a plan, REPowerEU. We have a plan production which right now has started to implement. So what we are going to do, if we don't have the time to find to implement this technology, this is my fear, and this is why I want to be ambitious, but also I want to give the opportunity in the industry to be adapted. I don't say, from my view and from my political party, that we want forever this adaptation, but we need to give a little bit more time, 1-2 years.
Thank you. Yeah, Hilde.
Thank you, Mr. Gebropoulos. I'm Hilde Dont. I'm here for the European Heat Pump Association. Europe has very recently launched the idea that we should have a Green Deal industrial plan. We should make sure that the Green Deal technologies are manufactured in the EU. Yeah? And it's a kind of reaction to what the US is doing on their side. And the great news is that heat pump manufacturing is mainly done in the EU. It's expanding, new factories are being built. But we all agree with you that an orderly transition is needed. The strange signal we are getting from the European Commission, Arno, is that we shouldn't worry. There is sufficient quota authorization available, and therefore there is no issue for the heat pump growth. But many people do not realize that the quota authorizations are not accessible for the EU industry. You can only access them if you produce outside the EU and import that equipment. So for us, this is completely contradictory to the Green Deal industrial plan. And I would like to hear your view on that.
Thank you. I think that the assessment has been done for the industry which is in EU. So it has been calculated for the whole industry, what is needed in order to produce heat pumps inside European Union, if I'm right or not.
What we have seen in the Commission impact assessment is that they first study how many heat pumps are needed for EU buildings, so what is needed to be placed on the market, and how much refrigerant is needed for that. We as industry also made that assessment, but then we would prefer that the majority of those needs are manufactured in the EU. And with the current quota that are being proposed, this would not be possible. We will have to move some of the production outside the EU and use quota
Thank you for the question that I don't have noticed.
We can, yeah.
I have noticed, I didn't notice the difference, but let me give a side, and if you want, we can come in contact again. Thank you very much.
If I have time for a question, thank you. My name is Leonie from FISMAN.
But it does need to be the last question because I have to go.
Okay, so I hope I don't monopolize your time. Thank you so much for coming and giving your input to this discussion. I just wanted to quickly also comment on the transition time necessary because, as you said, I think there is much to be said for a good balance because actually, at least for us, when we're investing, for us, an ambitious pathway towards natural refrigerants is preferable because it gives us certainty for investments because we know kind of like where the market goes, where we can invest and where we can prevent sunk investments. So I do say there is much to be said for a clear framework right now to make that transition happening with REPowerEU.
And this, yes, and I totally agree, and this transition need to be for all. And then we have get the signal, and we need to follow this pathway.
Thank you very much for joining us, Mr. Kimpopoulos. Yes, Mr. Kimpopoulos has to excuse himself. We were very, very happy to have received him, but he has to jump to another event, unfortunately. So now I'm going to go to the presentation again. I'm very sorry. We're up to the last presentation of the day, and it's a very important one. So as mentioned at the beginning, we try to give a balanced mix of speakers on opinions, and I think there's no better person to do this than Koen van der Sande, President of AREA, who is represents the Association of Refrigeration, Air Conditioning and Heat Pump Contractors, who will give us tell us about the risks of the rapid deployment of heat pumps based on natural refrigerants. Koen, the floor is yours.
Yes, thanks. So, Jasper introduced me. Okay, thanks. Yes, I work for my entire career in this sector. Been involved in area since 2009, and in the day-to-day business, I work for the Dutch National Association of Refrigeration, Air Conditioning, Heat Pump Contractors, NVKL, since 2009. And before that, I was working with contractors in our country. So that was the introduction of myself. And then about ARIA, I think not everybody is familiar with ARIA, but we are an association of associations, an European association of national associations, and our members are located in 21 countries. We have 24 national member associations, employing 110,000 people. Our contractors, the contracting industry in Europe is mainly dominated by small and medium enterprises, small companies. 90% are small companies, so that we have to bear that in mind. The average number of people employed by our members is 9, so really small companies. But nevertheless, our annual turnover is 23 billion euros. Obviously, our opinion is that contractors are the essential link between end users and manufacturers. The ambitions, if you've seen in the previous presentations, the ambitions of the EU. Area, the contracting industry fully subscribes the goals set by the EU and set out in the Green Deal, the Fit for 55 package, and more specific for our members, the F-gas regulation has a huge impact on our day-to-day business. So we play an important role in various transitions that is going to be needed to meet the ambitions set by the EU. And in the next slide, from the contractor's point of view, these are the main transitions we are facing. A transition from gas boilers to heat pumps. It's earlier mentioned today, but a lot of countries are used to gas boilers. In Netherlands, in the first place, but not only by legislation that transition is pushed, but since the war in Ukraine and the increasing energy prices, the demand for heat pumps has increased dramatically in our country, and all over Europe we see the same. Also earlier mentioned the transition from HFCs to low GWP refrigerants. That has a large impact on contractors. And the third, transition from separate heating, cooling, and ventilation units. That's needed to meet we need integrated solutions to meet the ambitions. Easier to install, easier to maintain, quicker. And the last one is digitalization. We have a traditional, conventional companies, small companies, and digitalization in equipment, in installation, but also in all processes in the country is still a large challenge for them. So today we are talking about natural refrigerants in heat pumps and the safety and risks about it. So yeah, in contractors we are used to. It's also earlier mentioned. We are used to install and maintain and service heat pumps charged with HFCs, and in our mindset we have to make a step a shift from that environmental thinking to safety thinking. We are all trained to keep them tight and to do leak checks, but still there is a significant leakage percentage in all through refrigeration and heat pump installations in Europe. So with charging with heat pumps with natural refrigerants introduces safety issues. And it's not only for contractors, but also for our customers, the entire chains, operators, also for enforcers, the public, animals, buildings, etc. So the consequences for contracting companies, we need to train, certify installers, engineers, but not only installers, the people who work within the companies of our customers, but also the engineers, people who work in the warehouses where they have to handle bottles with natural refrigerants. We also have to invest in tools, equipment, special vacuum pumps and that kind of things. Storage, we have to make safer storages to store the natural refrigerants, to transport them. A lot of things, and personal equipment that our mechanics are using in the field also has to be changed. It's going to take a lot of investment and time to adapt to the new refrigerants. Also, we have to make new safety procedures, work instructions, and risk assessments for safe handling and natural refrigerants. So, but not only that's not only the case for installers, but also for other stakeholders in the sector. There are a lot of consequences for specific for plumbers and heating contractors. They have make a huge step. They are used to install gas boilers, and they do that for decades. And they don't only have to make a shift to heat pumps, but now in the new situation, heat pumps charged with natural refrigerants. So that's for them it's a huge step. Not only the refrigerant technology, but also the safety issues that are introduced by natural refrigerants. For your knowledge, gas boilers are installed in half a day. For heat pumps, we need 2 days with 2 people. So a lot of extra time, a lot of extra people, a lot of extra hands that we are going to need, and all those hands need to be trained and instructed for safe handling the refrigerants, the new refrigerants that are used in the heat pumps. Also, the building owners, operators. Their people also need to be trained and be aware of the safety issues that could pop up with the systems charged with natural refrigerants. Our transporters, the people who carry the refrigerants to the projects, due to the ADR regulation. Enforcers who come, people representing the government, come to the projects, need to be trained, and also need to be need revised protocols to do the jobs. Certification bodies, they are also used to HFCs for decades, and now safety becomes in their mind, has to become part of their thinking and their protocols. Now the schools and training centers need to adapt their materials, but also the capacity of they need more teachers to train and educate the whole workforce. That is going to be more than tripled. And standardization institutes. We need all kinds of new standards to make good safety standards. So a lot of things to do, and that's why we plead for mandatory certification for companies and employees. Looking at the F-gas regulation, of course. So in Article 10, certification of persons and companies is captured. So that needs to be for natural refrigerants also. So it also counts for Article 5 leak checking. That becomes more and more important, because if a natural refrigerant leaks out of a system into the buildings of our customers, it causes safety issues. So Article 6, the safety of the leakage check, the leakage systems also need to be are necessary for safe handling. And Article 7 and 8.1, recovery, it's also earlier mentioned, need to be adapted to the naturals also. So we need a realistic phase-down schedule of F-gases, and the prohibitions of placing on the market of heat pumps, because we need time. We need at least another 4 years to prepare the sector for this transition. We need a holistic view regarding refrigerants. So no contradictions between F-gas and PFAS, for example. Today, we expect the report of the 5 countries regarding PFAS. So there have to be no contradiction between F-gas regulation and PFAS, the REACH regulation. So that's more or less my story. So I asked for awareness and for safety in Jesper. That's also why we made such a statement with the advertisement for the education. So that's the reason why we want to open people's eyes.
Thank you, Koen. I assume you're open for questions, and
of course.
Yeah. Armin, I assume that you have a comment.
Thank you very much for the nice presentation. Did I get you right? In 4 years, you're all ready just to install only natural working fluid heat pumps. That's what you said. The last sentence was, in 4 years, you're ready.
We need at least 4 years to train the current workforce for safe handling natural gases.
Yeah, but that's fine. In 4 years, the manufacturers are ready too, so we are online.
Yes, we need them. We need the manufacturers.
Good.
We need
it's good news.
Yes, that's good news. But the biggest challenge is in the plumbers and heating contractors industry. That's our members are used to work with refrigerants, and so that's we can solve it in 4 years. But again, the challenge is in the heat pump and of in the heating and plumbers corner.
Do you have an indication of, you said before that to train people that is used to install gas boilers into heat pumps with natural refrigerants is a big step. Do you have an idea of how much it needs to train a gas boiler expert into heat pumps, and then how much it takes from a heat pump expert to natural refrigerant?
Yeah, it's an whole different league, but the gas boiler guys are used to safety also. They use natural gases, so they have a safety mindset. But still they need to be trained to handle refrigeration systems. But then again, we need manufacturers to produce monoblocks, for example. Then the refrigerant is contained in one unit, and the refrigeration part becomes not so dominant anymore. So we need two ways. We need to train them, but also we need manufacturers to produce integrated solutions, plug-and-play solutions.
Okay, thank you. I think we have time for 1 or 2 more questions. We are running behind schedule, but it could be interesting. No more questions? Thank you so much, Koen, for the presentation and the answers.
Thank you.
Okay, so it's been a long afternoon already, but we're not there yet. We have a very interesting part now lined up for us. So that's the panel discussion, and I would invite the panelists to come take your seats at the front, preferably in the order that's on the screen. I think that makes it more clear. So, yeah, I don't think they need introduction anymore, right? But so Davide Sabadin, who's a Deputy Policy Manager, Climate at the European Environmental Bureau. And then next to him is Hilde Dont, so task force member on the refrigerants task force for the European Heat Pump Association. And again, so because she's replacing Thomas Novak here today, who could not make it due to unforeseen circumstances. Veerle Beraerts, Head of Technology, European Heating Industry. And of course, we've already seen Michael today, Michael Kofeld, who's a professor in refrigeration engineering at the Oslo University of Applied Sciences.
Even that one. Okay.
So,
again with the template and that. But you can have a look to see if the general thing is... The microphone is still on.
Okay, we're back good now. Sorry for that intrusion. So what we are going to do is start with, first a bit of an explanation on how this is going to go, because if we just allow questions here in left and right, then, the discussions, tend to flow a bit awkwardly. So we're going to have a semi-structured panel discussion, right? We're going to try to address all the topics. If we have the time for it, I can already tell you we're probably going to run over time. So we're going to start with an introduction round. Then we're going to go into into several key elements regarding the phase down of F-gases, being Repower EU targets, the manufacturing side of things, and then the training. And then if we have time left, we'll go for open questions from the audience at the end. But throughout the topics, we'll try to also already address questions from the audience, as much as we can. Right, so the introduction rounds. I'm going to give the floor to the three associations, because we've already heard from Michael. So I would ask you, can you please briefly introduce your association? I think most of us already know you, but just very briefly, and share your vision on the discussions today and the F-gas phase down that is under discussion. Does it work?
Okay, thank you. Okay, I'm Davide Sabadina, and I work for the European Environmental Bureau, which is basically the most historical and the largest presentation of green citizens NGOs in Europe that deals with everything environment. So we don't deal only with climate, we also deal with forests and chemical harm and the circular economy and whatnot. So this is relevant because the F-gas regulation also has some aspects related to potential chemical harm.
Good afternoon, I'm Hilde Dont, and as mentioned, I'm replacing here Thomas Novak on behalf of the European Heat Pump Association. It's the association that is the voice of the heat pump industry in Europe. Our members include heat pump manufacturers, but also component manufacturers, universities, test labs, and even energy utilities. Thanks for being here.
Hello, good evening, everyone. My name is Veerle Beelaert, as I was introduced, of course. So I represent the European heating industry. It's an association that represents manufacturers of hydronic heating systems. I mention hydronic because that's really important for our scope and also the rest of my story today. So when I'm talking, it will be about hydronics. But yes, we represent hydronic heating systems, including hydronic heat pumps. Of course, our members are now investing a lot into upgrading capacities for production of hydronic heat pumps to meet the REPowerEU targets of 10 million heat pumps in 2027. And to help us, we need to have an F-gas regulation that creates a safe environment for doing these investments that we're doing. And for this, as EHI, so the European heating industry, we want to have an ambitious F-gas regulation by moving to natural refrigerants where possible, but also allowing industry time to transition. And then for those appliances where natural refrigerants are not yet possible, to avoid the push to alternatives that might be harmful for the environment. All of this, we believe, will create a safe environment for these investments that we're trying to do and will help us move forward to reach the REPowerEU targets. Thank you.
Thank you very much. Yeah, Michael, if you have a...
Michael Kaufeld, and I've been working with natural refrigerants ever since 1987, so it's no...
We've seen that in the presentation. Okay, so yeah, we'll dig into the real meat of the debate. So REPowerEU targets, first topic that we're going to be addressing, and yeah, the first question is a question to Hilde. Right? Can you walk us through the REPowerEU targets related to heat pumps? What does this mean for the practical uptake until 2030 and beyond? And then, as a follow-up on that, what is the impact of the revised F-gas timeline on this? Can you talk about the critical period in the proposed timeline?
Thank you. A lot of questions. First of all, REPowerEU. Well, Veerle mentioned 10 million extra heat pumps, and it's 30 million by 2030 if you are talking about hydronic heat pumps. As European Heat Pump Association, we represent the diversity of heat pump solutions that is needed, so we do believe that REPowerEU can go up to 20 million heat pumps by 2026 and nearly 60 million heat pumps by 2030. And if you count, what was it, 2 persons for 2 days to install a heat pump, you can make the calculation. We do believe it's possible. Of course, combining an F-gas review and HFC phase down with the very strong heat pump growth will be extremely challenging. We acknowledge that. And we need to step up as manufacturers and as universities our research and development efforts to make it happen. And I would like to congratulate the researchers that presented their project today. It's a great example of the ongoing research towards alternatives. What speakers today also said, and I'm referring here to Koen, for example, from AREA, that we need the whole supply chain to be ready. It's not only R&D by the manufacturers, we also need the component manufacturers to be ready. We need the installers and the service technicians to be skilled and trained, and that will take several years because they have to work with flammable, sometimes toxic, sometimes high pressure refrigerant solutions. We also need to make sure that other players in the supply chain know what they're dealing with. It's logistic providers, it's warehousing, it's end-of-life treatment. Recycling companies are not yet used to treat products that could contain a lot of hydrocarbons, for example. We also need member states to update their building codes. 10 years after the first lower flammable refrigerants were introduced, there are still countries that have not yet updated their building codes and do not even allow to install a refrigerant like R32 in the buildings. I'm referring here to Austria, where it's still outdated. They're working on it, but it will take some years. I'm referring to France, I'm referring to Spain, and there are some others, Italy as well. Building codes were changed for the lower flammable refrigerants, but not yet for the higher flammable refrigerants. We also need member states to support the development of extended producer responsibility schemes. It's a proposal from Bas Eickhout that we very much support. Because in our industry, we will also need to use recycled and reclaimed refrigerants, for example, for servicing the existing bank of heat pumps. So yes, a lot needs to happen, and that's the challenge we are facing.
Thank you very much, Hilde. I'll open the floor to the panelists who, if you want to comment on this, I can imagine that there are different sides to the argument. Davide, if you want to answer first.
Yeah, thank you. Yeah, indeed. I think that we are we are living in exceptional times. We have a climate crisis that is worse every day. So it's like we're running a marathon and a sprint. And a sprint at the same time. Like we go to the holiday, to the Olympics, and then we are running the marathons, and we, the same people, are running the 100-meter sprint. And surprise, surprise, we have to win both competitions. The sprint marathon is the REPowerEU, and the sprint race is the REPowerEU, and the marathon is the climate, the decarbonization of our economy. So our climate fight that we have in place. So that means that we have to achieve REPowerEU and the decarbonization and the, let's say, getting rid of all climate harm that we produce in our economy. So for us, we think that's a very ambitious F-gas regulation is a means to an end to achieve the REPowerEU. It's not a problem to REPowerEU. Why am I saying this? There are many reasons, but for the sake of time, I'll stick to one reason. Okay, now if we have to install 30 million or even 60 million heat pumps, and then we think that the deep renovation ratio in Europe, as of now, is 0.2% of the building stock, yearly base. Now the Commission and then the legislators are looking at 2% rate in renovation. We ask, as civil society organization, for 3% renovation, which is very ambitious, but we hope we're going to get there. But even with 3% of the buildings renovated every year, chances are that many of these 30 million or 60 million heat pumps will be installed in buildings that are not renovated or not renovated yet. Those buildings don't work on 35 degrees. They don't work on 50 degrees. They work on high temperatures. They work on gas now, okay? And we want to get rid of the gas. So we need high temperature heat pumps. And by all means, the absolute majority of the heat pumps reaching those temperatures are working efficiently on natural refrigerants. So we have to move the sector as soon as possible to natural refrigerant exactly to achieve the amount of the heat pumps that we need for the REPowerEU. Otherwise, we will never get there. With low temperature or mid temperature heat pumps only. So this is one of the key reasons why we believe there's no contradictions in phasing out the F-gas, going for natural refrigerants in the heat pump sector, and achieving the results of the REPowerEU. And the second thing is that we have 70 million tons equivalent CO2 reserve in store in the system, okay? And that's equivalent roughly to, I mean, by the time the Commission made the study, to 7 years of heat pumps. Now, of course, it's going to be less than 7 years because we're scaling up the production, but still, quite a lot of, let's say, leeway there that is not taken into account. That's also part of the story.
Thank you, Davide. So yes, Veerle, I'll ask you for immediate follow-up. We've heard. Yeah.
So yes, indeed. I mean, we fully agree with you, Hilde, that I mean, the supply chain needs to be ready, but we also believe, at least for the products that we represent, that at least for some of those, we can transition to natural refrigerants within, of course, a feasible timescale. I think what the Commission is proposing, 2025, would be a bit too early, but we can definitely discuss for those products some timing.
Okay, thank you. And as the last follow-up, Michael, you have a...
Yeah, just one comment from own experience, and something we also have to work on when changing from gas furnaces or oil furnaces to heat pumps. Like the heating companies or the plumbers, they are used to that the difference if you install a gas furnace with 15 kilowatt and you install one with 30 kilowatt, the difference is maybe €1,000 for the consumer. So they always played it safe and installed a bigger one. I had that experience with my own house. It was an old house. The original oil furnace had 50 kilowatt. And there was no one who wanted to install anything below 26. And I had done my own calculations. I said, oh, something like 12 or 13 would be enough because I did some installation. I finally found a company. They installed the gas furnace 14 kilowatt. I couldn't find anyone who wanted to install a heat pump, but the gas furnace with 14 kilowatt. And then looking over the 6 years of operation, it never used more than 12 kilowatt. So in terms of a heat pump, if you install a heat pump with 12 kilowatt or one with 24 kilowatt, it's not €1,000 more for the consumer, but it's maybe 10,000 more. So there's something which we also have to train the technicians to really estimate the heating load correctly.
Okay, thank you. Yeah, Hilde, if you...
Well, Thomas said online, we all agreed here, we have to stop using fossil fuels for heating as soon as possible. We all agreed that heat pumps are a great solution for that. What was also interesting from the socio-economic study, that there's a big concern on the affordability of that transition. And this is the challenge we as manufacturers also have. We have to come up with solutions that are affordable, to make that transition from a gas boiler to a heat pump. And every heat pump installed, even today, even with the current energy mix, is already better for the climate than not installing a heat pump. I think we all agree on that.
Okay. Are there any questions from the audience? Try to keep it, on the REPowerEU targets. Any comments, inputs to this debate?
I can only talk about cost in Switzerland because this is what I'm used to. So probably this picture changed a bit in other countries. But the cost of a heat pump unit, if one heat pump with a synthetic refrigerant costs 10,000 and one with propane costs 11,000, in Switzerland at least is irrelevant because the installation costs 35 to 40,000. So the affordability in that case, I don't think plays a role in this specific case. Yeah.
Yeah, that could be the case for Switzerland, which I think has a bit higher wealth of living than other countries. What we have seen, especially in Central European countries, is that they very much want to move away quite fast from the gas boilers. They feel the Russian war at their borders, and they really focus on affordability. And then you see that solutions like air-to-air heat pumps very fast make their way to that market because it's very energy efficient, it's affordable, they don't need to have floor heating or radiators even. They're changing from their gas convectors to air heat pumps. So this is the diversity we need in Europe. Every country is a bit different. Air-to-air heat pumps are very popular in Nordic countries. Finland, it's 80% of the market. In France, it's also the case. In Germany, it's different. We heard a lot about Germany today. So every country has their own specific conditions, and we have to make sure that REPowerEU and the F-gas regulation allows for that diversity to be taken place.
Thank you. So, any follow-up questions? No. So, yeah, maybe about the impact assessment of on the F-gas regulation. Did it, because this has also been mentioned during the discussion last week, I think, in the European Parliament. Did it take enough into account the REPowerEU targets? Arno already, mentioned it today as well. But did it, according to you, did it take it into account enough or not?
Me again? Okay.
We're all open. But
well, no, we don't think so, exactly because of the diversity of heat pumps that are necessary on the market. I know, Tim, you have referred to impact assessment where air conditioners are also considered as an air-to-air heat pump, but we have seen in the assessment, also in the GIZ studies, by the way, that it's very much focused on a single split air-to-air that is primarily designed for cooling, and that there was no proper assessment done for such units being used for heating, including for multiple rooms in the building. So that's a gap in the impact assessment of the Commission, Arno, and we would like to explain that a bit more in detail in the upcoming weeks.
Would you like to comment on that, Arno, or you don't feel forced, but?
Happy to speak to Hilde, of course, and follow up on our impact assessment. I also wanted to make a comment on what you were said earlier to our Greek guy. Always forget his name, it's not that easy, the rapporteur of the EPP, because it's based on a misunderstanding or misrepresentation. So it's not, we did analyze it, as I said, how much quota you need, and it's not just the 70 million CO2 tons for exports lying around that make up a buffer. There are different buffers in the quota system. There is, for instance, the IPR use that you as your company doesn't like very much, but we know, for instance, that the car AC producers use quite a bit. So there's several million ton CO2 equivalent of quota that is allotted for that's not being used. We know that from the reporting. And there's also an over-allocation, I call it this way, for the MDI, because we're putting into the quota system a starting date for the MDIs that is based on a very high growth scenario that will most likely not be met. So we have an over-allocation in this sector. So there is a number of buffers in that sector which then can buffer away this additional heat pump need that came in with the REPower discussions at the very late stage of our F-gas regulation. But we have double-checked it, and it's not, in the impact assessment, you see a back-of-the-envelope analysis. We have done a full remodeling afterwards, and as I said, there are these different things, and it's not just the import things that are buffering this away. So that's why we are confident that the quota system as proposed is ambitious, but feasible.
If I may comment on this specific point and on the timing issue, because I think that where we're going, I think we all shared where we're going, the destination. There's a timing difference here that maybe where we have discrepancies. Let's not forget that in both Annex 4 and at Article 11, if I'm not mistaken, there are possibilities for the European Commission to make exceptions. I mean, there are many ways you can work that out. I mean, it can be exception. There are mechanisms can be improved for this exception, for sure, but the exceptions are already there to make sure that in case the quota system is not fit for purpose for that specific application in that specific year, the Commission can always say, okay, let's take a picture of what's happening. Is it, did we go too far? Did we not? Did the market not follow up? There's not enough. I mean, nobody will be left in cold, okay? Because there's always a possibility to say, okay, let's give it one more year for this application, because there is an exception. We're not tying our hands like and throwing ourselves into the river, So why not trying to be ambitious, set ambitious timelines, and for the bans particularly, give a clear signal to the industry, and then only in case industry does not deliver, this is to be proved, okay? Then we have safety measures, and then we can enact those safety measures.
Thank you very much. I think we have to move on unless, so there's a, I know that EHI has worked on the derogations as well, but we can move on to the next topic because we're running a bit out of time. So yeah, it's been mentioned quite a bit already, right, during this discussion. So the manufacturing side of things, the impact on the value chain and the production. So this question is actually to Veerle. Can you tell us about the readiness of manufacturers for a switch to natural refrigerants, which has been widely discussed already today, in the commercial and residential sectors? Can you explain us more about the issues the industry would face, and is the proposed timeline feasible for the industry to make this switch from the perspective of your members?
Okay, thanks. Yes, well, I can tell you that some of our members are already producing hydronic heat pumps with natural refrigerants. And those are also quickly ramping up the production, so multiplying production capacity to make more of them. But of course, we also have members that are still in the development phase or still thinking about how to develop them. So we have, in the full range, we have people who are ready and people who are not ready. It's of course clear that our members are investing a lot. I mean, we're speaking about over 2 billion euros for the upgrading of the production capacity of heat pumps in the next couple of years. So that's a lot of money that goes into it. But of course, setting up new production and switching to natural refrigerants takes time. 2025, that would leave less than 1 year to make all of this happen, so to transition completely. And that's, of course, I mean, in our perspective, too short, because, of course, the whole supply chain needs to follow, and that's not that obvious. Therefore, what we think for the F-gas regulation, what is really necessary, because we have so many different heat pumps for so many different applications, to make a differentiation at least between hydronic heat pumps and air-to-air heat pumps to come to reasonable and appropriate solution for those appliances. And then when we look at the bans for those, we propose a two-step approach for hydronic heat pumps. The first step would be to switch to a GWP of 750 for all hydronic heat pumps up to 70 kilowatt. And then the second step would be for those appliances that can switch to natural refrigerants to switch to natural refrigerants. And when I say those appliances that can do it, I'm speaking about the monoblock units that are installed outdoors up to 70 kilowatts. So for us, these can transition by 2030 to natural refrigerants. And of course, I mean, quickly on the impact assessment and Repower EU, I would like to say that in our view, for hydronic heat pumps, the targets that, well, the quota will be sufficient, but to make absolutely sure, we would still recommend that the Commission monitors and analyzes the situation. And if hydronic heat pumps cannot be taken up quickly enough, that something is done about it, and same for servicing and maintenance. That's it.
Thank you, Veerle. Yeah, just a quick follow-up question to Michael. Michael, I've mentioned it before, but besides being an esteemed professor, you're also director of Steinbach's, which is a knowledge center that helps companies making a switch to natural refrigerants in the German market. So what's your take on this and the change in the production line for manufacturers?
As I said in my presentation, and as we also heard before today, I mean, there's no hocus pocus in changing to hydrocarbons. And we heard how Heim is doing it even for an indoor unit. It is feasible, but of course, yeah, I mean, I think the biggest challenge is in the production area. If you have a heat pump manufacturing business where you produce several hundred or maybe thousands per day or per week, then you need a larger quantity of propane. And that was when, in the early 1990s, when the refrigerator industry changed from R12 to isobutane. The biggest challenge was in the manufacturing, not at the consumer. And also with the heat pumps, I mean, you can make the heat pumps safe, and especially hydronic ones is easy. And in air-to-air, there are examples, and of course they're not from Europe, but the change from R22 to propane was financed with German money. at Chinese manufacturers, Indian manufacturers making single split air conditioning / heat pump units air to air with propane.
So air to air heat pumps based on propane. That's okay. Yeah. Because that's often, as used as one of the types that are the hardest to make the switch to natural refrigerants. But yeah, as you said in your presentation, it's not always the case. Davide, would you like to comment?
I'd like to comment back on this air-to-air heat pump, which is hovering over us. The topic is, let's just come clear on this. I mean, it's not that the technology is not there. We have a problem. There are two problems. The technology is not being installed widely in the market. European, there are some installation, but it's not, because it's on the installer's responsibility to deal with these flammable refrigerants, and also because in some countries, this is not allowed. But it's not the case of all countries. We have installations in Germany, in the Netherlands, and Belgium, and companies have installed this. And it's there in the market. The other problem is that we might not want to lose the whole market to non-European producers, but that's for European producers to catch up. So these products are sold in hundreds of thousands outside Europe, and they're working perfectly, okay? So it's not that it's not there technically, so that's why we don't make a distinction between the two different heat pumps, because we cannot afford it in terms of climate to make a distinction. We just have to understand that, of course, these products bring more challenges in terms of installation, training, and education of the consumers and whatnot. But in terms of quota, I think Arno already replied. And in terms of technology, I think it's also important to say that it's not a problem of technology. Of course, there are some specific issues, which are the ones of kind of big, a little bit like more splits units. And then, of course, these ones are the ones that might have a need for a little bit more time. But when it comes to the vast majority of domestic use, the products are there already on the market.
Hilde, I saw you shake your head no.
No, it's fine. I will not dwell into the technical details. There was a presenter that mentioned about the safety standards. And it's not just hydronic versus air-to-air. The safety has to be considered in view of where is the refrigerant circuit. Is it fully outside the building? Then you can use more propane, for example, than if the refrigerant goes inside the building. And then it depends on the room size, the countermeasures you're taking, how far you can go. This is why researchers indeed are looking at how far can we go with only 150 grams. And that was a Fraunhofer brine-to-water heat pump, if I remember well. So yes, everybody in the industry is looking at how far can we go within the safety boundaries that we have to respect. We want to place safe products on the market. And you always have to balance the safety, the capacity, the energy efficiency, and the affordability, and the GWP in that exercise. So it's not a simple, straightforward answer we can give here. I'm also in the energy efficiency task force of the UN. I can recommend you to read that chapter. It very much focuses on what's the balance between the thermodynamic characteristics of the refrigerant, ammonia being great, the cost, the affordability, the energy efficiency you can reach. So recommended reading, but it's not a black and white answer here.
Okay, thank you, Hilde. Is there an input from the audience on this? We have to be quite quick, though. So, yeah.
Thank you, Mihai Scompiero with Mitsubishi Electric. A quick question on the panel. I mean, transition times are key, and that's transpiring from this clearly. One element was not discussed too much today is, of course, technologically at the R&D level, anything can be done. What do we do about the components? For instance, the critical ones, like the heart of any heat pump, the compressor, for instance, that would run on hydrocarbons. Imagine this transition being done in 2-3 years, like the Commission wishes. Who do you think will supply such large numbers of compressors? We manufacture them, and we're the maximum capacity. Who do you think will supply the power semiconductors? Look around what's happening with the big GAFA companies. they're all reporting downturns in sales because simply they didn't have the semiconductors to create phones and so on. We make them too. And they will come into all the advanced heat pump technologies. Without those, where is the autonomous, where do you think they'll come from? They all will not come from Europe, I can tell you that. The same with the heat exchangers, so looking forward to hearing. We were talking about nice, dreamy thing in Europe, but they all come from outside, guys. There is no strategic autonomy. Thank you.
Very interesting question. Davide?
Yeah, I think that we can also have a reply to this. It's interesting. It comes from Mitsubishi. That thanks for the I don't know. I can say. Do you want some names of companies? The Embraco, Dorin, Danfoss. I mean, I can tell you there are plenty of producers of compressors that are moving very quickly to big and small, to natural refrigerants. And very quick. I can tell you also that there's a 20. I mean, I'm following, being in Italian, I'm following a bit more the things happening in Italy. But I know there's 20 Italian companies across the whole value chains that are pushing for ambitious F-gas. It's called Unione Italiana del Caldo del Freddo Green. Among which they also have producers of compressors. And you have also producers of IT and all the electronics needed for this, Schneider Electrics and others. So I mean, it's coming up quick. Okay, nobody says that in February 2023 you have all the products. We're not looking at February 2023. We're looking at a few years, but things are happening very quickly. And if you give the right signal, they will be there. Eventually, of course, there will be. Of course, we're in a global market, as now there will be also non-European products in the market. And as it comes to shortage, I mean, the shortage of critical materials apply to all sorts of heat pumps in the end, the very end, not only the natural refrigerants one. So it's kind of a critical problem that we have across the value chains, regardless of the refrigerants.
Yeah. Okay. Yes. One more question, and then we'll go on with the topic because we have to. Oh, running out of time, right? We're already over time.
Thank you very much, Emilie Stum from Panasonic. We hear from the panel Hilde mentioning different type of heat pumps, indoor, outdoor. Verily mentioning hydronic. What we see, maybe also a question for Mr. Cashel from DG Climate, is we see currently, as phrased in the proposal, the bans are not very clear. Also considering we see the amendment from the Parliament coming up, it's a bit all over the place. Is there any progress on clarifying what is meant? Because I think also for the market it's important to talk the same language, because otherwise we'll have issues in moving forward, and we also get questions from also the supply chain, the partners and so on. So it's quite important there, and would be interested to understand a bit more also from Mr. Cashel if there is any progress there, and also from the panel. He's not there anymore. Oh, he left. Okay.
Unfortunately, he had to leave at 6.
Sorry, I did not see that.
Yeah. It's very true what you're saying, and we see it also in the Parliament debate and so on. Very much industry associations have acknowledged that, including EHPA, and I think in the coming weeks we will see more concrete proposals even coming from the associations to help shape the regulation. Because it is a very good example. We can be proud of it in Europe. I think we should be proud of it again, but then we have to do it in an orderly way, not in a big mess where you then have to come back and say, oh, it was too severe, let's ask for exemptions, let's change it again. Let's do it right from the start so that we have the path to follow for the future, for a decarbonized future. Thank you.
Thank you. Any other answers to this from the panel? You have just an interesting discussion, so we can follow up on it. Any replies? No. Okay. Then we shall move on. We really don't have a lot of time.
There is one question from the online participants. Is there any time?
We don't have much time, unfortunately, because it's already 6:10, and we have one more topic to discuss, which we will discuss in about 5. I mean, you have 5 minutes time for it maximum. So yeah, Davide, regarding training and addressing the skills gap, how can we, I have to ask the question first. How can we ensure that the training, that the skills gap is addressed with keeping the integration of natural refrigerants in mind? Can you talk to us about, how you see this, possible solutions to this? What's EEB's point of view on this?
I was hoping for a less elaborate question. Well, I think that we have three things we have to focus on. First of all, we need national members to be proactive actors in this field, not just taking note of what's happening or what's not happening in their territories. Okay, so personally, the EB proposed the fact that we need to have roadmaps at the national level with clear key action point, key performance point, KPIs, meaning how many professionals you've trained by 2025, 2026, with 100% or that horizon by at least 2030. So some figures, I say, you have to reach the full working force training in order to have results, because otherwise, as it stands now, it just says that me as a member state, I just send a paper saying yes, there have been training we have adapted the training, and then there have been some trainings in my country. It doesn't say we reach X percent, 10%, if it's enough to deliver the Repower EU. Second thing, we need to certainly help the companies to produce products that are more easy to install and plug-in products. It's already happening. Many companies are already going that direction to simplify the installation, but we need more than that. And the third thing I like to mention is that we need emergency training now. I mean, now we're waiting for, if everything goes well, this enters into force in 2024. By the time the member states adopt the legislation on the training and then register what's happening in the market and call all the stakeholders, we're looking at years. By the time when this gets moving, the timeline of the Repower EU is already done. So we need some parallel process from the Commission, together with the installers and the professionals, together with the member states, to kickstart something which is external, maybe with virtual reality, something that is more harmonized across the whole of the European Union, because we have to train many more professionals than we have today. So also to be clear on the natural refrigerants and the trainings that we had before. If now we have, out of 10 professionals, only 2 professionals trained on natural refrigerants and 8 professionals not trained on natural refrigerants, certainly it is a problem, but what we have to look at is the fact that we probably have to go to 100 professionals, so we have to look at the 90 new professionals that will be training across the whole spectrum of the gases, so that now if you leave 8 people behind, it's less of a problem because you have 92 that are ready for the task. So that's what we have to look at, what the missing one, the guys that are now installing gas boilers, the guys that are now installing something else which is not natural, is not heat pumps, and that will be trained on all the gases. That's what we think is the way forward, but to achieve this in time for Repower EU, something more is needed than what is there in the F-gas.
Okay, short follow-ups by the other panelists. Try to keep it as brief as possible, please.
Well, we actually support AREA very much. It's not only about training, it's certification. As manufacturers, we do want to be sure that the people have their certificate, so just training is not enough. And we support your amendment proposals for the F-gas review.
From our perspective, so we have been trying to work on the topic of installers and upskilling and reskilling people who previously were installing gas boilers and still are. But what we see, so the landscape in Europe is very diverse. So to make one training schedule for the whole of Europe, you would have to look in each member state, in each region, what is missing to upgrade that. We also see that the installers companies who currently install boilers are quite small SMEs, 3 to 5 people, and are not willing to retrain themselves. The attractiveness to the profession is a bit lacking. So it's not only about what we can offer and how we can train. We are willing to retrain people, but it's also about what happens in the field and how these people want to be retrained and to see the necessity to be retrained. So it's a very complex problem that we are trying to solve together with the Commission and together with interested parties, but it's not an easy one to tackle.
Michael, do you have a follow-up on installers parts?
Just, this last topic is right. I mean, the small companies, they can't afford sending people for a week to training. So this training should somehow be paid for. Instead of that the company has to pay for the training, then they should get money if they send their people for training.
From the quotas. Okay, we're going to have to round off here. I'd maybe ask all panelists if you want to have a concluding remark for 30 seconds maximum, please. Try to keep it very limited. So what are your thoughts on the discussions today? You know, after this panel discussion, how do you see it evolving further?
Just one important thing. In order to make the flammable refrigerants more safe, use charge reduction. That's the key topic. And there's one thing which I found in the bathroom. It's like 30 years ago, we made an investigation of how much propane is in a spray can. And in a spray can like this, 30 years ago, contained about 100 to 180 grams propane. This one now contains 25 grams. So the manufacturers have learned how to reduce the charge of flammable gases. And that's the same which we need to learn in the heat pump industry, to reduce the refrigerant charge.
Thanks. I think it's quite clear. I mean, the industry, but everyone around here today is ready to decarbonize the sector. But the question really is how and how fast. I mean, there are different solutions to going to the same goal. And yeah, I think many of these discussions will be necessary probably still to reach to the right, the right pathway, let's say.
I very much concur with what Veerle says. I think there's a great future ahead for heat pumps towards carbon neutrality in 2050 and all the steps we need to take in between. We do hope that the F-gas review facilitates that transition and is not a stumbling block for it. So we very much we want to work together with all the market players to make it a successful transition.
And from our side, I think I really hope that decision makers will take into consideration the elephant in the room, which is the climate change and climate crisis that we're fighting. Okay, so if we only consider the economical side, the feasibility, the safety, it's somehow challenging, but you have to consider that we have to win. We cannot just play. We play to win here because we have no alternatives. And then as they always say, when you want to reach something, the solution is out there if you have enough money or enough time. I think we have an unprecedented amount of money being invested in our economy in the time we're living now. It's a matter of pushing more money to gain time and make it quicker. The example of the virus against the coronavirus. I mean, against the coronavirus. We have the vaccine. Sorry, that was developed in much quicker times than usual. Is a clear example. You need a lot of money to make it quicker, to make it work, and to win the fight. In this case, it's climate. It's not less important, and then we have to always remember that's the reason why we're doing this regulation.
Thank you, all panelists. Thank you very much. I'm not all going to keep you here longer. It's 6:20. We went way over time. Sorry that we couldn't address all questions from the audience, but I really want to thank everyone for coming. I want to thank all the speakers for the great presentation. I want to thank the panelists for the great discussions, and you again for the questions, of course. So thank you, and I wish you all a good evening. Hope you found it interesting.